Screen one, I'm assuming. Right, you should be able to see. Oh no, it's all gone. Oh yeah, it's gone that funny way again, hasn't it? Okay. Q&A. So can you see my primary screen?
Yes.
Okay, great.
That's not legitimately your logo, is it, Neil?
Oh, part of it is.
Right.
I had 60 seconds to come up with something, and I remember he had a Twitter profile picture of a Rottweiler, and I thought I don't want to do him an injustice and not use his company logo, and I thought, but a Rottweiler like with a bone, and the bones, I thought, yeah, it's nice. So there you go. You're right. Is that okay?
Yeah, all good, mate. Yeah, of course it is. Yeah, of course it is.
Oh, right, Dave.
What, mate?
Cue the musical intervention bit and start.
Well, this is live. There's no music. You've got to edit that bit in your YouTube pad. Just do it in your head.
Yeah, right.
Let's go.
Catchy music. Let's go. Okay, let me just move that bit of paper. Hello, everybody. Welcome to our third of our webinars. This one's going to be, again, slightly different because unlike the domestic ones, which is a very, and I've said this all along, the domestic is full of lots of complexities, lots of challenges, lots of human factors and interfaces and social challenges and emotional elements that come into the job that it shouldn't do, but it does. Commercial is very much financially and time constrained. Industrials really is a different kettle of fish, and that's why I kind of asked Neil to come on as Paul's replacement. So thank you very much, Neil. So what we'll do is my mouse ever works. Every time I do this, the mouse never works. Remind ourselves, in the industrial game, is it fair to say, Neil, the average age of the industrial spark is a little bit, there's a lot of the seasoned veterans in the industrial game?
Yeah, I'd say so.
And for those who
I definitely say that's where you get a lot of career sparks.
Yeah. If you see Clarks of the world and stuff, they, time served, they spend their entire careers getting a pension and all the rest of it. So again, a lot of the older chaps or ladies, C1, C2, C3, C4 was the last time it was in 16th edition Amendment 2, caused a lot of conflict. I mean, Neil, what do you remember about this as you're one of our new hosts today?
Well, what I do remember, obviously I do remember them. So I qualified in the Yellow Book on the 16th. That was when I qualified. So this was, and back then testing wasn't really pushed like it is now. It was. I remember working on we'd done some flats in Whitechapel, and it's new build. And I remember that we had a tester, just a newly employed tester on the firm. And it was like he was like this magician that come around and do these magical things on silly money, and no one else really knew what he'd done. So it wasn't really something that I had a great dealing with until later on. Sort of when did this fizzle out? When did it get replaced?
2004 was the last edition it had it in.
So I think I qualified about 2000, 2001, something like that. So. I didn't see much of this as what I would call a fully competent electrician, but I do remember them.
You raised a good point as well in this is testing. When I was again doing my industrial side of my apprenticeship, the heavy rail stuff, the inspection testing wasn't done until the very end of everything was installed, and then one of the governors would turn up with this thing called a mega, and would then do the applied tests, and it was very, very minimal. It was only with the birth of Part P, dare we say that word?
Yeah, I think.
Did people start heavily getting into testing?
I can't. I mean, I've not looked at the library of the archive of regs like you've got behind you, Paul. But I think most of the time, the purpose of testing has often been verification, checking your completed work, just checking it when it's done. Whilst obviously we've had that reapproach of initial verification, and during the process they've just really blown it up. And it was about that Yellow Book in the 16th. I think it was 1997-ish when the 2391 course itself came in.
It was in the first edition as well as a note. The testing of wires, the frequency cannot be lightly stressed. Right. So anyway, we're not going to talk about the first edition. So this was an interesting one. It caused a lot of problems on industrial. It had the same problem if it was domestic commercial. It confused people. Well, let's go now on to what we know and love. C1s for those present who are maybe new to testing or new to coding of electrical installations. A C1 is danger present, risk of injury, immediate reaction required. I can see it, I can touch it, it will kill me now. That's your C1s. C2, potentially dangerous, urgent remedial action required. I've always viewed this, lads, tell me if you disagree, that one thing needs to fail or happen for it to become a C1. That's the measure between the two.
Single action.
Single action, indeed. C3, improvement recommended. That, again, is in the eye of the inspector. That's where in my opinion, in my engineering judgment, in my perception of risk, there is improvement here. And then you can evidence it accordingly, but there is no immediate danger or no potential danger. And then the last one, FI, everybody's favorite, everybody's friend. We want to give it a big hug. Further investigation required about delay. I always call that the time stop one. But in my brain, I've always started with investigate in your brain and work your way through, which is why I'm an FI farmer. Sorry.
So in terms of how I treat a C3, I'd be interested to hear people in the chat and you two guys. I treat C3 as everything that's not captured anything else that could be allocated a code gets a C3. So if it's not danger present, if it's not potentially dangerous, it doesn't need further investigation. That's what I tend to use a C3 for.
So would that be maybe a non-conformity with the current version of BS 7671, or would it be an example of poor workmanship that may not specifically be a non-compliance with a regulation, or be both?
Both, to be honest with you. Workmanship's covered, isn't it, in BS 761? So yeah, I would, anything that I don't consider C1, C2 or an FI, and I can put a code against a regulation number against it, I think it's important that the client understands that to their current edition there is non-conformances, although they may not be very important.
I mean, Eddie said in the chat, 4 should never have been removed, full stop. Obviously, C4, the old 4 was non-compliance with BS 7671. It created a huge list.
I kind of agree with that, but the trouble is then you've got what's the difference between that thin line between a C3 and a C4? Now, it may be more robust actually to say improvement recommended. I mean, some people have suggested that we could have a code that's just crap. C4 would be, I can quote a reg number. What would C3 be? That would be an engineering assessment, maybe. Where there's multiple other regulations. Maybe there could be a code where the C3 becomes does not comply with 7671, and there's another one for outside of scope of 7671.
I mean, there are different perspectives, because I mean there are some codable items of the old C4, like a switch line not properly identified, maybe sheathing missing from a bare CPC, which wouldn't push you to think that it's potentially going to become a C2 in the future, or it's going to move beyond. It's just going to stay there. And technically, there's not a problem with that. That could be on that code. But some C3s today, people want C3s because they don't want a C2. Because as I said last week, they don't want a C2 because they don't want the outcome of a C2. So we're talking about, right now we're talking the guiding on buried cables in the wall. We're talking about maybe SPD or absence of SPDs and things where maybe in the future that actually may need to be escalated towards a C2. Right now, for example, we're talking so much about type A RCDs. And we know the problem with ACRCDs, and it wouldn't be completely stupid to think that maybe in 5-10 years, we might start seeing that creeping into the C3 to the C2 territory if there's ACRCDs. It's
inevitable. Dave, you and I both know from the many, many, many evenings we've spent reading M603, 64 stat suite standards that the type A RCD, if it isn't there, is eventually going to become a codable
and
thing,
the absence of an AFDD.
And it will creep its way up. It will creep its way in slowly but surely.
Yeah. Do you think it'll be codable?
Be more honest about it.
Do you think it'd be codable? Just the fact that it is the incorrect type of RCD. If you went to a property and it tested fine, the test button operated as it would, and everything's fine, would that change it if it was operating as it should be?
Yes.
There's two sides to that for me. I mean, fundamentally, the testing process of RCDs to the guidance says that you should remove all of the equipment. So I would probably want to get a leakage clamp meter or something to show me what the leakage clamp would be as well. which we have discussed. If we can if we can develop that part of the testing to get an understanding of how much leakage current is on that RCD, because this is the problem: is if we test an RCD to guidance notes 3, we've removed all of the potential leakage on the device, and we're testing the device with no leakage on it. So it could give us a pass, but when we put it into service, it may no longer be satisfactory, and that's the bridge that we've got to get across right now. And again, that's in industrial, that's in commercial, that's in domestic, that's broad scale. But when you think about continuity, when you think about improvement recommended, if I go to a board today, and I find, let's say I go to your railway pool, and I find one of your old boards has got all type EICR CBOs. Technically, there's nothing saying there's anything to code for that. But with my understanding of the A type coming in and my understanding of where we're going to go with this, because I look at 60364 so much, I could say to you now that there's a recommended for improvement, because just look at the trend, look at the technology, look at your equipment as you move forward, because you want security to continue as a business. I'm not saying you must change this right now, but I'm saying, if we look and if we do a bit of research, we can see the way the industry is going to go. We can see the way technology goes.
For me, just on that subject matter alone, it's a C3 already, because one of the big problem is it's already an external influence. It's already in the annexes, DC and an AC network, etc. And if we have manufacturers, there's a regulation, we have to follow manufacturers' guidelines. We know the likes of Valiant produce boilers that require Type B RCDs. So if we're ignoring that and we have that knowledge, and Dave, you've said something that's, I'm not going to say frustrates me or the other sentence, but yes, when we test, it does boil something. When we test and we are testing only the domain of the fixed wiring, we are missing a trick with the connected loads, because we may select and erect something for an intended use or utilization. Okay, but if the connected loads are mutually interfering, then that's a problem. And we are now in the world of EMC, EMI, which is the wiring regulations, as we've said previously with people, is heavily predominant on thermal. It doesn't really cover, well, it does, nobody really covers it in training or anything. I think chapter 33, compatibility or maintainability, it talks about DC leakage in there. There's whole sections in the regs.
It's one of those areas it's one of those areas in legacy of training which we have just dillied and dallied and tiptoed around. We've avoided it, and we've not actually kind of studied it and brought it into training because there's no time. There's no time. Same with over voltage protection. There's just no time in those 3 days that we squeeze regulations training into.
Chapter 33, compatibility. Or assessment shall be made of characteristics of equipment like to have harmful effects on electrical equipment or other services likely to impair the supply. Coordination of concerned parties, transient voltages, under voltage, balance loads, fluctuating loads, starting currents, harmonic earth leakage, excessive protective earth conductor current, DC feedback. We don't look at this.
Thing is, again, most courses, the lecturer's going to go, oh, those are long words. Let's move on.
Yes. They did in my 18th edition.
And that's it.
And the problem is a lot of the people on the course will go, thank you very much.
Thank you very much. Let's move on. They will.
But then what will happen is when something occurs and everyone goes, oh, it sparks, you can sort that out. We won't have the knowledge or understanding of how to analyze and break this down. And that's the problem, I think. But anyway, let's move on.
Let's move on.
Because we could do a webinar just on that. It gets confusing with some people. Right. So this is the main reason everybody argues over coding. Obviously, the judge, and people seem to think that they're going to appear in front of a judge. And as we've always said, the answer may not lie in the wiring regulations. It may lie in the electricity work regulation. Regulation 29, defence. Have you taken all reasonable steps to discharge your duty to avoid the commissioning of an offence? That's one of the key regulations I say to a lot of electricians. Yes, learn 6 pages of fundamental principles, but electricity work regulations, that's the document, that's the thing you need to tattoo into your brain. I want to cover this again. Now I know everyone's going, oh bloody hell. Go on.
This is where it's interesting where we start to go into the industrial sector in terms of courts and law.
Liabilities.
This is where most contractors need public professional indemnity insurance, because equally, if you start to overcode and over insist on doing work that could be argued as unnecessary, then you could equally find yourself in court for taken by the client saying that you've made them to do unnecessary work and they want that cost back. This is where you're going. This is where it's fundamentally different from the domestic sector. There's people on the other end that will be looking, if some people, some not very nice clients may be going, look, you've caused us to shut down unnecessarily for 2 days while you've done this work. I want that recuperated.
This is why a lot of electricians are so firm in their want to stick to a guidance, an industry guidance, something they can immediately just put up to actually lean on in circumstances just like that, as to why they made those decisions.
And every single guidance book, as you know, will have on page 1, 2, or 3, you are not to use this as your Bible. You use this to assist your coding and your professional judgment.
Yeah.
The codes that you make should be yours. And we forget that as an industry.
Because technically, it is impossible for me to write a book that will give guaranteed codes that are acceptable across industries and in all environments with all clients, with all levels of competence. It can't be published because there's so many different varies there. And that's which is why we go to this. It's why we go to this document that Paul's about to go to, which we have to assess ourselves and prepare ourselves.
Well, what I did was rather than reading this out to you, I cherry picked the things that an inspector I think are relevant. The first bullet point Neil is very good at: be prepared to challenge assumptions and proposals, ensure safety receives appropriate consideration. In the industrial world, we are absolutely swamped with due diligence, health and safety policies, briefings, toolbox talks. All sorts, work safe, home safe, beyond zero, 100% safe, all of these various
KPIs, all these things.
Yeah. There's lots more management actions.
Yeah.
Now, I haven't taken these and written these myself. These are all in the document. Strive to be involved to identify potential problems. An inspector does that. Look purely beyond technical considerations to address non-technical, human, organisational, and cultural. If Neil wants to shut my railway, for instance, he needs to consider that when he's finding C1s and C2s and how he advises his clients. And that's what makes industrial a very much a unique skill set or competency that you have to develop over time. I think that's fair to say. Adopt conservative decision-making, quantify your risks with relevancy sufficiently and support by evidence. Be responsive to changes in operating environment. You might not be able to test when you want. You may need to test. Perfect example is again, I'll use my the DLR. They did EICRs at night with the traction power off. Every single RCD passed every time. Did it during the day, every single RCD failed.
Yeah.
Pointless. Ripped them all out.
I had the same in the food industry when I did thermal imaging. They said, we're quiet then. I said, I need to come when you're under full demand.
Yep.
And there are some tactics where you go, let's do 40% and let's calculate the rest. You can't calculate demand when impedances, non-linear loads come into play. You've got to incorporate full demands. And
this document is really good because it asks us to bear in mind that risk assessment should be used as an aid to judgment, not a substitute. And that's really, really key. Be aware that developing over elaborate procedures can lead to poor compliance. Some companies have such ridiculous levels of process and controls. Me and Neil know what we're talking about in this one, that the actual doing the job and fixing the problem can take months when it's something very simple. Be prepared to engage in public debate. That's what we're doing. This will go on YouTube. It becomes a record of public debate amongst inspectors who are commenting on the webinar and ourselves. Explain the quantitative aspects of risk with clarity and supporting evidence. Be honest and clear about your uncertainties and prepared to challenge misrepresentations, which is where a lot of the debates start. And my favorite one, encourage an open reporting approach and a spirit of questioning and learning from others. And this is where I put the codes on the seesaw of risk and how do we balance it. So yeah, that's kind of a summary of that really. If you haven't watched the other webinars, please download that document. I've just looked at the text. Mark Holmes emailed Worcester Bosch 7 days ago about ICD type for a boiler. Still waiting for a reply. Yeah, good luck because they've pretty much closed down for COVID. And I've noticed they recently did a giveaway. Buy a boiler and get a Type A fuse spur for free.
Supplied by your AC type RCD.
Yeah, supplied by your AC type. So that's
I think a very British boiler install company, very, very British they are actually training their engineers now to replace spurs.
I think I know that company. They like to do mini training competencies for their workers, don't they?
Safe isolation and the rest and all this sort of thing. Yeah, it's
right. Yeah. So let's get into this now.
Right, go.
Of those pictures, everybody, what is commercial? What is industrial? Because this is a debate we had offline as to what actually constitutes industrial. Because to me, a railway, let's just throw it in there. A railway is industrial, but Dave immediately says, no, it's not, it's commercial. So I thought I'd throw some pictures in there and let everybody debate as to whether they think the selection and erection, the inspection, the criteria.
What kind of noise was that you just made?
What?
What was that? What was that noise you just made?
Oh, I'm sitting on a leather chair. Sorry, it's
was
squeaking.
that? All right, something pinched, did it?
Yeah.
Right. Okay. Yes.
Oh.
Okay. All right. Fine.
It's a squeaky brand new chair. It's a fucking nightmare.
Oh.
Sorry.
Some lovers' tiff going on here, ladies and gentlemen.
Okay. So
Sorry.
industrial, you say? Okay. Go. Okay.
Yes.
Explain away.
So the bottom right, I would say, is an industrial electrical installation. The top right, I would argue, is commercial. The top left is, I would suggest, industrial. And the bottom left, I would say, also is industrial. And the one in the centre is also industrial. Now, the reason I say that... You what?
I agree completely.
Oh, good. The reason I say that now, I know, Dave, would you like to tell
These
me why
railway
you think
boys
railways...
stick together. That's what I've learned.
Sorry.
This now.
Sorry, but...
I was always I've always been under the emphasis when I can't remember where it was. I basically referenced it, but commercial is where you make money. You do something to make money. And industry is where you make something. So,
yes. And there is definitions on that. You're right.
There are probably areas of railway where you are in commerce, and there probably are areas of railway where you are in industrious. Fair to say?
So this is where I completely agree with you, because if you go to like King's Cross, St Pancras, the shops, the retail, absolutely industrial. Sorry, absolutely commercial, not industrial. Apologies. Yeah. But when do you then take commercial? So the ideal example is, let's look at a Westfield shopping centre. Everyone watching, we've all been to a Westfield. Yes, it's commercial by its very nature, but the electrical installation, due to the magnitude of energy and connected loads, it's going to be industrial. The monitoring, the load management, everything about that is industrial.
You're saying industrial is dependent upon the loading and the method of utilising electricity,
well,
or
let me tell you something.
What the place is doing.
So there are two sets of IEC, International Electrotechnical Committee.
There he goes. He's fucking been researching
standards.
this.
I have not been researching this at all, and I don't like
you just found this right now, did you?
This is why we were late today.
Right. No, it was because you two were talking. Each for two groups of defined environments. Okay, so the EMC stands, and this is where I've always kind of been taught from when I joined rail industry, was railways have a heavy industrial electromagnetic environment. It is just because of the nature of railways, 25,000 volts, 750 volts on the floor, etc. Signalling, track circuits, all that good stuff. So with general EMC, there's emissions, radiated and conducted, and there's also equipment that has to be immune from radiated and conducted emissions. So the standards have residential, commercial and light industrial. That includes houses, shops and business premises, cinemas, sports centres, workshops and labs. So you could, in theory, buy something for your home that could still work in a cinema, potentially. But industrial locations with industrial, scientific and medical equipment and installations involving high currents and associated magnetic fields, or in which there is frequent switching of heavy and inductive capacitive loads. And that happens on rail because there are large loads. Now, if I picked a small station, let's say, I don't know, Epping on London Underground, small station.
Are you talking about electrification though?
No, I'm talking about the electromagnetic environment, all of it. Okay, because if you go onto a railway, you don't have a shop. You have a shop with 25,000 volts, about 3 or 4 meters.
So you're saying Tesco Express at one of your stations is industrial?
No, the internal fit out is commercial, but the electromagnetic environment.
Is everyone following this?
It's true. It's true. So
okay.
if
I got you.
Because on railways, Neil, back me up here, or maybe not.
Neil,
don't back me up. So on railways, all of the earthing schemes are connected together. Okay, yes. So where you have a Tesco, let's say a Tesco Metro on a railway station, that will be connected into the station earthing. The station earthing is connected into the traction return. So when the train comes in, everything will rise and fall at the same voltage. That's how railways work. Now, would that be considered an industrial method of managing EMC? I would suggest it could be.
Yeah, it makes sense.
I think we're differentiating what the Joe on the street would call a commercial industrial.
Yes.
setting.
Yeah. No, we're going heavier into it.
To more the electrical influences that may influence our decision-making process.
So, I mean, many industrial places may have a commercial part on their infrastructure.
Yes.
You know, does that mean you would? I mean, say for example, if I go to a factory, there'll be administrative locations, there'll be welfare locations, and whilst I might go, oh, they're all industrial, the level of risk adjusts. Yeah?
Yes,
there are people who go to work who never go into the factory.
So I'll give you a
people who
perfect
go to work
example.
who never actually put on PPE. They just go to a computer and then go out.
I'll give you a great example of a little pop-up shop on a railway station. Turned up, plugged into a railway station, no problem at all. They had lots of electronics and stuff on their stand, and every time the train came in, all the light bulbs got brighter. Some of the equipment that they had plugged in was burning out. It was chaos and mayhem. Why? Because that 13-volt socket was plugged into a rather large few thousand amp bus bar system, and everything was just going everywhere. Now, on these, and for anyone who wants to research this more, that's why I put this in as a piece of knowledge, BSEN 50121 is the Railway Emissions and Immunity Standards. BSEN 50122 is the Railway Earthing Standards, which will teach you lots about railways. And if you want to understand any EMC product standard or issue that could happen to a product that you buy, BSEN 61000 suite of standards is product immunity. And if you want to look specifically, 61006-2 2019 is the industrial product standard. So I could, in theory, turn around to Neil and say, right, Neil, if you're buying any products, you should check that it's compliant with 61000-6-2 industrial immunity standard for products.
Can you stop quoting BS standards? Because otherwise Dave Betteridge is going to be broke.
Sorry.
By
the end of the webinar. You know,
sorry. I learned this. I'll tell you where I learned all this from. All right. Shepherd's Bush, when we connected the lighting in, there was a Dali system.
Yeah.
And we connected it all up. It was brilliant. It was a lovely little job. And we were going to re-energize it the next night and do the ZS testing. And I was there the early morning. The first train came through and all the lights started switching on. And then they were dimming and they were going all over the shop. And I was like, what the hell was all this about? And it was coupling from the train that was telling the Dali system to switch on, dim, and do all these other things. And that was the first time I heard about EMC and just wanted to understand it. And
it's amazing how many things you hear about when you experience them.
Yes.
First, a lot of electricians don't hear about things until they actually study a phenomena that they're having to cope with.
But this phenomena is now starting to encroach into the domestic world. It already happens in the commercial world, and it most certainly happens in the industrial world, although industrial, a lot of things just go bang more than anything else. But it can affect, as we know, and we'll show you at the end of this, I've got a perfect example of it.
Okay, dokie. Right. What are we looking at here?
Right, this is a DNO head. This was sent in from Mr. Burke on Instagram. P. Burke and Sons up in Newcastle.
Did you see on Instagram this morning, he had this cutter doing a conduit?
Yeah,
I never had these toys when I was.
No, they have. Mr. Burke, it's fair to say, is the king of Milwaukee tools.
Awesome stuff.
But yeah, so this was a DNO head he found in an industrial, because his family does a lot of industrial, heavy commercial fit out. And this is one for the ages. This is, I've zoomed in on the offending article, but you find that, what would you code that? How do you even start? So it's obviously a DNO intake, but someone's been, I don't know, is lazy, naughty? Run the poll.
I'm running.
Cool. I can't vote. Of course I can't.
So
We've got to
are we
discuss
looking
it.
at something like two 25s or 16s, a look like 25 mil towels, sort of massively stripped back and then twined together to make them
together to go into that.
I'm assuming they've been stripped and then twisted together.
Yes. It's mind blowing, isn't it? It's a good one.
I can't vote.
No, you're not allowed to. We've got to discuss it. That way we look stupid if we get it wrong.
I'll look at the polls. I'll look at the poll settings if I can adjust that in a minute. Everyone else is voting. They're still voting.
FI.
I'll give it a couple of seconds. FI.
No. C2 for me. One thing goes wrong and that's dangerous. It's poor workmanship materials anyway, to be honest with you.
Yeah, I mean, I could ask all these silly questions. Is it readily accessible? All this stuff. But I mean, it's going to be a C2. You need to get that improved, don't we?
C2 all day long, as far as I'm concerned. One thing I don't know is insulation tape actually insulation?
There's two sides of that. Obviously, when you look at cable jointers and stuff, there's a specific Scotch 3M tape which is passed as insulating medium if installed properly because it achieves some kind of dielectric strengthening. But then if you look at BS 7671, 416 does say that insulation shall only be removed by destruction or the use of a tool. And then you question if I can peel that off.
Fingertips in.
Yeah. You know, is this tooling? Yeah. No. So you have there's two perspectives for that. It achieves an insulating medium if it's the right tape type. It's got to be a specific tape type, and I don't think this is. This is mainly used for identification, if I'm correct. This kind of coloured stuff. But yeah, it's if you can remove it. 416 does say that, you know, if it's insulation, you cannot remove it unless you destroy it or use a specific tool. And so I would go to that with this kind of stuff.
But also, I'd also see to this, because this is something that with the you have to forgive me if I got the manufacturer wrong. Is it the whisker the things now that clamp the towels? Because I mean, there's no security for that to be grabbed and pulled out. There's no security of the clamping of the cables to make sure there's not going to be used as a coat hanger.
Yeah, prevention of strain on conductors.
Right, let's see what we've got. No, I agree. Yeah, I mean, we glance past these tails all the time. But yeah, there we go. 87% C2.
8%. Good on you.
87%. I'm going to read. I'll read out the winning one because obviously the recording doesn't catch it. 87% C2. Good.
Great. Right. Let's. If my computer works again. Oh, I need to throw this out the window. So this is an interesting one that. So this is one from my personal collection. So this was found on a Crossrail enabling project 14 years ago. And it was a, what do you call them? A concrete batching yard in West London. And the concrete batching yard was basically, we were going into that land area and we were throwing them out. And so they'd left this building redundant and we were stripping it out. And when we took, obviously, the cables out and the tails, we found that inside the main fuse, the main switch gear. If you were doing an EICR, I thought, what would you code that? Because that has taken some serious effort. Serious effort. 100 amp fuse. It's fitting in the main switch for a cement batching yard.
Is there a time limit you want to let to pass before we start throwing codes out, or is it just throw them out?
I'm just throwing it in there.
Just throw your opinion, yeah.
Well,
quick and dirty.
As much as it pains me to say this after Paul constantly throw me under the bus for the non-FIs I raise, I'm going to FI this because I'd want to know more about what the cause of that was before I coded it. It's definitely a C2 as a minimum, but I'm on the fence if it's a C2 or C1, so I'd want to further investigate that.
He has just done what I did last at the first one, C2 and FI.
It's two coded.
Which I agree with. I would C2 and FI it.
I've written safety processes for companies, and we know where we companies that want processes and training to authorize their workers to go to a panel and reset a breaker, because you have to tell them if you've got a breaker that's tripped and you reset it and it trips again, don't keep trying to do that, you know, because the device, the electro energy is going to then just smack you in the face. And so if we have evidence of this kind of fault, we then need to investigate further, especially if it's not popped it, or if it's a device that doesn't pop. So I agree. We need to investigate really the cause of this issue instead of just coding this as well.
And this is where it's important to understand where the reporting stops and the fault finding starts.
Yeah.
I'm very much of the opinion I'm here to produce a report on how your installation is now, and then give you as much information as I can using the tests that were carried out.
And fundamentally,
I'm not really going to go into the realms of fault finding.
And fundamentally, that's a condition of the way it is utilized. But again, you can only do as much as has been agreed.
Now, the good thing is I actually got to meet the guy who, one of the guys who worked at the batching yard, because we had some civils issues as well. And one of the former managers turned up there, and I did ask him, did you ever actually have any power blowouts? And he said, I've been here about 20 years. I think we had one, but we've never had any since. Wonder why.
Yeah.
Wonder why. Cable industry getting hot.
So the poll on this one is a split with C1s and C2s.
I can see. I can see why.
Which,
if that was
last
operational and you found that, you'd be saying that needs to go out of service. Yeah.
And last week, Richard Townsend was basically saying, well, at this point, in both situations, it's going to be unsatisfactory. So you're happy. But yeah, half have gone, 42%
Well, yeah, they're
C1.
right, because, I mean, effectively, you don't have
C2.
fuse protection, so you're waiting for a fault. So for me, that's why I've picked a C2. I need an incident for that to become a C1.
Yeah,
I sort of heard what Richard said last week, and the thing that was on my mind was that obviously we're not in control of people's budgets, and we don't know how much they've got, and it may well be that a company's really struggling, and they can only afford to do the C1s. So it is really important that we do get them C1s and C2s as accurate as we really feel comfortable.
As accurate as we can. Yeah. Again, I mean, this goes back to what Mel Manville would say. Oh, I'd make if I had a C1, C2 kind of thing. If there was spares of these, if I could access a wholesaler to get me a new thing, I could then just elevate that to a C1 to do that, as long as the client's happy for that work to be done.
Well, let's
and we're making the system safer. Okay.
I think there was a good balance. There's some good judgment in that.
That was a dead split between C1s and C2s.
Yeah, I thought there was some good judgment on it, but for me, it's definitely a C2, and the FI would be a stern bollocking. And I
agree. I agree. To me, it's a C2 because there's only a problem if a fault exists.
Yes.
If so that's it. But the conclusion is the same.
I'd be very surprised if that fuse was designed to operate in that way.
Yeah.
So something's wrong.
So here's another one. This is in a workshop of a garage. One of my big bugbears in life is corrosion and containment. Just porous walls, sticking containment straight onto porous walls. I said it. Oh, here we go. It's disappeared again. Yeah, porous walls, corrosion over time. You've got the bit of plywood which the board's mounted onto. That's obviously had some sort of water leak or water damage over time. And yeah, that's your main tails. That's your main intake.
And let's replace it with galvanized trunking again.
Yeah, absolutely.
Touched on that last week. If we just take that lid off and replace it with the same problem, so this would require a bit more work.
GRP is not a myth. It's available. We can get it now. We can do it. But yeah, so it's a good one.
Would you want to investigate further to see if there's actually, physical damage here, or is it just surface corrosion?
As an inspector, yes, I would start at C3. It requires improvement, but I
maybe just test it with your pen to see if it goes through the thing.
Oh, yeah, I mean, I've got video footage of floors where you can put your fingers through the joists and stuff, but for me, I would be starting at a C3 because that's within a controlled area as well. It's probably worth noting that. But it's crap. It needs further investigation because there could be a water ingress problem. But what I find is there are certain builds where the minute you mount onto any sort of porous brick surface, especially if there isn't an air gap behind that wall, you'll find you'll just get damp condense coming in. And this is why when I did my apprenticeship, I was always taught put Unistrut on the wall. Something that's you can see the signs of corrosion.
Well, again, I've seen the same with a thermal camera where you put a panel on the wall. The actual, a lot of feeder pillars that might be single skin where there's solar loading, they actually will warm up those panels. You need a bit of spacing for heat impact and also for moisture.
In fairness, I do like GRP Unistrut now. I think that's a cracking idea because that's a great barrier to prevent that corrosion spreading.
Yeah, question in the chat here, which I will raise because I know this is a passion for you, Paul, that you hate. Bending radius on some of those tails, David says.
I know, it's fucking awful.
These this little
awful.
This little tactic of little pigtails and L3 in particular there looks a little bit.
So, but can I tell you something? As someone who's done metering training, that is an endorsed and approved helix that they will actually say to you if you haven't got the space, bring the tail up and do a helix and put it in. They don't give a toss about bending radiuses on the metering companies. Don't ask me why.
Okey-dokey.
Don't.
So for
That's
me,
a very good one.
So for me, this is a C3 unless that trunking is a CPC. Then I'd up it to a C2.
Which you raised last week about your experience in the rail.
It doesn't look like it is in this case, but that would be the only caveat. So based on the photo, this is a C3 for me.
Yeah, we'll come on to that, funnily enough. That's a good
and,
shout.
The pole has got a 44% C3.
Yeah.
36% FI, because they want to obviously look at the condition of this trunking.
But this is what I like about coding debates is you build a picture and your brain then wants to know more, wants to investigate more, understand more.
I mean, what I can't see from this photo is the angle is obviously those tails, are they carrying on all the way through to the fuses and there's no single insulation exposure from the outer sheath being stripped in the trunking? If that's been stripped into the trunking, then there's a bit more
So
risk.
as the inspector,
So
would you take the trunking lid off given the condition of it?
I probably would not want to touch it
Yeah,
because
would
I
be the
then have
same,
a problem.
I'd
I
stick
would,
your torch underneath and above.
yeah, I'd get a torch on the top and I'd get my eye level down below. And if I can see grey at the top of the fuse holders, so I know that double insulation is most likely sound throughout, then again, C3.
In my
no, I agree.
opinion, I would expect my guys to be accessing that. If we're thinking of we're here as an industrial electrician, plenty of notice of this work would have been given to the client. This has been planned in over many, many months, probably. It may well be the first shutdown or series of shutdowns they've had in a long time. This would be my opportunity, I think, to get in there and get to the bottom as much possible, get in there as much as we can under this period, not knowing when it might happen again.
What
So
Neil hasn't told you is Neil issues his guys brown trousers for this specific piece of work so that they can go home and not be embarrassed.
Can I bring up something in
Yeah, go
the
on.
chat?
Okay, go on. Sorry, I haven't looked at it.
I'm going to apologise because I think it's gone a bit crazy. But one of the guys in there said the problem with C3 and everything is it's not going to get done, and that to me is something that's not our problem. What doesn't get done is not for the inspector to worry about. What we've got to do is inspect using our engineering judgment and code appropriately based on the hazards that may or may not be there, and give accurate reporting to the client. What they do with that report, that's their business. As Paul likes to say, you've given that responsibility back to them.
You've taken all reasonable steps, Neil, and this is where the inspector then hands over to the likes of the managing director or the person issuing the report to the person ordering the work, and that's where that danger notification can come in, because you could have a report that's got, say, 25 C3s on a big warehouse somewhere, and a couple of C2, C1s. Now, you can still issue a danger notification on the cumulative effect of those C3s, because you could turn around and say, look, in my opinion, this installation will be dangerous in the next 5 years. I have to take all reasonable steps, so I'm going to issue this form to you. Those sorts of small things push clients to do the work. And I don't mean push them in an ethical way. There's enough standards out there outside of the scope 7671. There's enough health and safety legislation that if we push our boundaries in doing our discharging of our duty of care, you can ensure that the work does occur. And we did cover that in our asset management webinar a little bit, where we coded and used asset management terminology to help them understand the remaining life of the asset and the operational impact, and that's where the C3s get done. But some clients are just bastards. They're uneducated bastards, and they'll never do that. And then that's why the danger notification.
And
I've got a pack on my shelf.
It's fair to say that there shouldn't be a C3 and a danger notification. It should never happen, because you'd highlight it under a C2
reason.
or C1.
I use that term if I'm working for a bastard, by the way.
So, I mean, in this particular image, in an industrial location, this could be a room that no one ever goes into except for the electrician. I mean, this might be a place where they store cleaning stuff. They shouldn't, but some places will do that. But it might be a completely dead void space. So the next person in here is going to be probably you the next time round. Does that in any way escalate the need for you to fix this?
But then you're talking control measures, aren't you?
It's like Neil said that he would want his guys to look into this. So I'm thinking, okay, well, in that case, would you, with your client, get pre-authorization for the risk of damage from dismantling? Because if you take that lid off and that rust obviously comes away and you can't put it back, have you agreed that some dismantling might warrant a remedial cost for the inspection? Or have you got maybe a coffers to cover some repair work from your dismantling?
Do you know what? You've nailed it on the head there, actually. And I think we probably didn't touch upon it enough at the start. That extent and limitation is not only crucial, but in industrial, I agree with you. If you're doing an EICR, it may be a very good thing, and I'm sure Neil will agree with me here, where you do have a small pot of money for these sorts of things to happen, where you'd say, look, I don't know, I'm going in, I'm doing this. It may be of such a poor state that just coming near to the damn thing causes some sort of failure. I can put a provisional sum in where if this happens, I take a photo, time, date stamped, I send it to you for a thumbs up, and while I'm there, I can get it done, get it addressed, etc., or plan the work in.
Yeah, I've seen this covered many ways. Sometimes the client will agree on no more than £50 a C1, something like that, which could quite easily be done. I mean, sometimes to take a C1 away to a C2 or even a C3 is relatively a quick thing. Other things have been happened where if you're in some sort of a maintenance term contract, that the contractor will raise a reactive order, maybe £1,000 or something for the term of that inspection, that you can spend up to £1,000 creating stuff. It's all about relationships with your client. Be open and honest. And my dad always said, every business is people business. If you're a good person, if you're honest, open, treat people, give people the right information, they will trust you. They will listen to what you've got to say, and 9 times out of 10 act properly.
Ken, all you're doing is working within your own competence and and authorization. They've got you to do that, and you don't have to completely overwhelm them with engineering waffle. Just common sense of risk.
And also, in terms of it's such a big question in terms of where are you testing? You know, if this is like there's a place in Eastleigh, it's called the Eastleigh Long Welded Rail Depot. It's where there's only 2 places that make all the railways, the actual physical rails in the country. Now, to get that shut down is really difficult. It happens once. I think they have 7 days a year. It's a 24/7 operation.
A lot happens when that goes down.
And they don't want to be hitting there going, oh, we've got to wait another year before we do a C2 or C3 repair. They want that done. So there's got to be this has got to be agreed up front, as you said at the start, David. Start agreeing this thing up front. If you're a competent contractor in doing this sort of work, you should see these pitfalls months before they happen.
That's a key word you've just said, that they're competent, because again, if you're on a site and you're assessing risk, you should really have the skills, the tools, the workmanship to remedy or to make safe at least that risk. Otherwise, you're basically, you're working competently. I can't think of it any other way. We have got, did I share that one? Or I can't remember. It's this one I shared. This one? C3s. I think it's this one. C3s and FIs. Yeah. Yep. I've already done this. Yeah, we've got 44% C3 and 36% FI.
So
19% C2.
Just look at me. Just having a quick look at the comments before we move on.
Yes.
Can you give a certificate shorter than 5 years? Of course you can. Can we have the elephant in the room debate quickly? That schedule in guidance note 3 with the frequencies, and stop looking at it. Look at the bits before and after it. That it's about engineering judgment.
Yeah. It'll most likely disappear soon anyway. It's disappearing from the code of the PAT testing book.
So my understanding is that the guidance note 3, the thing we talk about, that is for designers from verification to first inspection.
Correct.
So when we carry out a design, I will sit there and I will put part of that this is to be inspected initially. 3 to 5 years is normally where I go. After that, it's down to the inspector on the ground. They choose. I've signed things off for 6 months before.
Yeah,
again, it's very unusual, but...
But in that period, from initial verification to the first periodic, the utilization may have changed, the demand may have changed, environmental characteristics may have changed. So you can't repeat and regurgitate frequencies. It must always be reassessed.
It's one of these rules of thumb, hearsay things have caught on, and it happens a lot in our industry. It really does. But kick that one straight into touch. It's
unfortunately,
the inspector.
A lot of people doing this work want, as we said earlier on, they want guidance to lean on.
Rule of thumb.
Because as you said, if you test too frequently, if you do too much, if you don't test enough, you've got to find that equilibrium where you're actually not in shit street. And you've got to have your own engineering judgment and background to support you on that. And a lot of electricians don't feel confident in getting that.
And sometimes it's client pressure. Sorry, Paul. Sometimes it's client pressure.
Gotcha.
They expect a 5-year inspection. But where'd you get that from?
They don't just expect it. They financially plan for it. They
plan for it.
Exactly.
And that's because in industrial and commercial, they forecast their budgets and they have chartered surveyors who have these guidelines that are issued to them by industry bodies who say, we have guidelines. Follow this, and that's what you can financially plan for. Well, they don't actually say, by the way, if this is a 50-year-old building, it's going to cost you 3 times that amount. And then poor old contractors going, well, I need to do all this work. This is a really bad state. I'm losing money here because my clients treat me like crap because of a book that the chartered surveyor issued 10 years ago.
A food manufacturer I work with, I've worked with all of their factories. They've got over 50 factories in the UK and some abroad. I've done all the electrical safety rules with them. I've done the thermal imaging protocols. I've done some other work with them. I've done competency assessments with them. And I know the engineers really, really, really well. And they've looked at their competency matrix. They developed their own assessment methods. Some of them are chartered engineers. Some of them are even, members. And I think there's a couple of fellows in there. And we said about things like PAT testing. They go, no, I want to use my contractor that I use, that I trust, that I know will do the job properly. He'll do it correctly. Any costs or amount that I have in my budget. And they'll go with that plan. Then some prat from a head office who's nowhere near related to that factory from procurement will go, no. Use this nationwide approved contractor that does it at 40p an item. Basically cuts the bollocks off.
Yeah. Yep, completely agree. Right, moving on from PAT testing, because we want to get done in record time.
To your sandwich.
This is, sorry.
Oh, has your McDonald's arrived?
Yeah, my McDonald's arrived. So I haven't eaten all day. I know I'm fat enough, but hey.
All right, what are we looking at here?
Two-compartment trunking.
Yep.
Ooh, fixed base connectors.
Yeah. It's connector blocks on a cable. So you're an inspector. You've come along here. You've opened it up. It's heavily corroded, but that didn't stop you opening it up. And this is the mess you found. As you can see, there's exposed singles there. There's bonds in there. You can kind of make out the divide. The top part has immediately, my eyes are attracted to those connector blocks that are screwed into the back of the trunking. But I'm looking at a number of things, rusted fixings. It's cable management at height.
So what voltages have we got in here, roughly?
So we've got a mixture. We've got comms voltages and we've got LV voltages.
So we've got band 1 and band 2 systems.
Yes, band 1, band 2. And that connector is actually, just to give everyone a clue, that connector, before we run the poll, is actually a PA speaker. So it's a public address system. And that's because it was in a very, 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 very large airport. One of the biggest in the UK. Back a house.
Okay. Let's run a poll. Is there anything else we need to know about this?
That's it, really. It's just a rusty trunking running around a boiler room.
Alrighty, yeah.
I'm not too concerned about this. I'm swaying towards a C3, probably between C3 and no code, really, because the corrosion does very much look like superficial corrosion. So, but
more worried about the fixings, to be honest with you.
What I do spot is the twin and earth. Now, I look at that and go, right, I've got someone here that thinks this needs metallic mechanical protection and someone else who doesn't. So which one of them's right, which one of them's wrong? I would hazard a guess that twin and earth shouldn't be there, but that is just a guess based on the photo we've got. So I'm more concerned about the twin and earth than I am about what's inside the trunking, to be honest.
I'm looking at this from the rear of the trunking is corroded. I'm looking at the fixings, which are corroded. Remember, we took the lid off, so that's fine. So Neil is absolutely right. It is a lot of superficial trunking. But
was this on the wall? Sorry.
Yes, it's on the wall. So if it's coming through the back, then again, if I look at one failure, could that potentially be dangerous? So I'm kind of, if I can sit on the fence between a C3 and a C2, I would. But if I did, I'd probably need to go to hospital to have the splinters taken out my arse. So I'm probably going to go for a C2.
I'm going to ask another question. Is the PA system on this installation used to announce an emergency situation at the airport?
Good question.
Yes, it is.
Good question.
That changes it completely, doesn't it? Absolutely changes it.
Life safety systems. Yep. Absolutely.
Yeah, I would.
Let's run the poll.
I'm saying this. I would C2 FI. To put it with the fire people to have a look at.
Just remember, everybody, Neil is the one FIing all today.
I know, I'm so annoyed.
Yeah. No, that's. I was on a C3. I was on a C3 until Neil asked that question, basically. So yeah.
Okay, let's get the poll run.
We have got 76% C3.
I love
16% C2.
I know it sounds mad. Yeah, I love that. I love what I'm seeing on that poll as well, because it's good. C3 is a good best place to start. And again, it's that application of more questioning. And
I was on a C3 right until someone said about the potential of it being an essential or a safety system that could obviously fail if those fixes.
Yeah, I was on a C3, to be fair. I
was on a C2. I was just waiting for Neil to do it. And fine.
Awesome.
Okay, great. Right, next one. This is a classic.
Ooh.
So now industrial, and the reason I've put these photos in, industrial brings all sorts of weird, fancy stuff. And it's fair to say industrial can bring some classic electrical installations and some bespoke electrical installations. So this, I'm going to look at the chat and see if anyone can guess what this is. Now, it's obviously a consumer unit. It's an old one. They're 3871 breakers. They're Crabtree ones. It's a three-phase board, but if you look really, really carefully, if you look at the bottom right nut, you can see there's a green and yellow conductor there. And if you look here at these orange cables, because they are orange, they're bolted into what is a converted three-phase board. So what does everyone in the chat think it is? Yes, bang on. It's 110 volt. It's an old 110 board. Well done, everyone on the chat. But the thing is if you joined, the point being is if you joined from domestic or commercial into industrial, there may be confusion. And this is where the extent and limitation of your own knowledge and not being afraid to ask questions of the utilization of the installation and knowing your own abilities to identify this. This is a classic picture. This was actually installed Oxford Circus. This was right deep down the middle of the underground, bespoke panel with the guts bespoke made, very old panel, fantastic old piece of engineering solution, really. But yeah, it was 55 volt, not 55 volt center tap, bespoke double pole breakers, classic, really. But so would you code that? If you were doing it now against the 18th, and what would you code it as? Let's run a poll and see what people say.
There's so much going on in this photo.
There is.
You've got poor terminations. I'd say lack of labelling, lack of identification. Bare ends not terminated anywhere.
So it used to be in the London Underground standard that all 110 volt was wired in orange. Whoever come up with that was a buffoon.
Yeah, I'm not sure if that's thermal. That Adrian said, is that thermal damage? That could be thermal damage. In my opinion, I think it's just greasy hands, but I am guessing.
It's dust.
It looks like age.
It's dust from a failed IP seal. So heavy, if you go deep down on the underground, the piston effect of the trains, unless you have fully IP rated stuff, then what you end up is with pressure just pushing dust into it. If you look on the underground today, you'll see loads of IP65 lights, but behind them it isn't IP rated, and the dust just gets in the back and fills the glass. So the glasses all fill up with dust. So if you're going to apply IP ratings, apply it correctly and install it correctly. Otherwise, it becomes detrimental to the
That's just changed it all for me now. Thinking, see, as I'm going to verbally go through what I'm thinking. So I'm thinking London Underground Station, closed environment, electrical distribution, oily dust being pushed into that distribution, switching, tripping. I'm starting to think differently now that Paul's gone down that road. And where I was looking, thinking, well, this is probably just a C3. I'm now veering towards a C2, based on where we are, the danger if that does go bang, what the mass panic, major station, huge potential of evacuation and problems.
What did this supply?
Different beast.
So this actually is a standard detail across most London Underground stations, and it supplies the 110 volt cleaner sockets, which have to be every 30 meters on a platform because they limit the extension leads by 15 meters. Good question.
Okay.
But yeah, they're everywhere.
I'm going to say C2, just based on the IP rating. Clearly, something needs to be looked at in terms of getting that dust in there. Shouldn't be in there.
Yeah, I would probably want to look at just obviously the connections and the risks of arcing contacts with that contamination in there. If I see that contamination getting into those points of arcing or contacting there, then I would be C2 in that as well. Otherwise,
there's no spaces from the. Is it?
Yeah.
It's...
Otherwise, I would just it needs improvement at least.
It's old, and I'm a C3 on this.
It's also interesting. When do we start looking at people maintaining this? They're taking that cover off. There's no safe barriers. There's no.
Yep.
Are we looking at that as well? Has anyone thought about that in the chat? Thinking, hold up, Is this now an acceptable method to be working on?
We have maintainability, and how many times have we seen panels and control panels where there's been additional barriers put into them? We go to panels now where we're trying to divide up the mechanical from the electrical from the air. We're trying to segregate these services in panels, and you shouldn't open up a panel and have unnecessary exposure. You should have IP2X minimum.
Here's another one for you if you haven't already voted. Size of those conductors. The length of platforms are about 130 meters. Volt drop on 55 volt is extreme with those sorts of 4 mils. You're not going to get any sort of compliant volt drop. In actual fact, one of the biggest problems was, and this is a legacy item on the underground, was if you design a 110 volt system now on the underground, you're going to run at least a 35 mil into a junction box and then come down with, say, a minimum of 6 mil to your sockets, just to try and achieve the ZSs and compliant volt drop. Here, London Underground would literally just run a 4 mil ring or radial, and that was it. They didn't care. Just put on rings. Wasn't considered, wasn't an issue.
So that length, potentially the ADS requirements are probably not achievable. They would need to be looked into.
Yeah.
So
which would push it into a C2.
Yeah, so that would push into a C2.
Well, I would code that on a visual based on what I'm seeing. I'd go C3, and if I considered it more on applied engineering judgment and people questioned me, I would say, well, the installation itself sits at a C2 because under fault conditions, has anybody checked the ZSs? Will they pass?
When you've got long lengths, I always look at the ZSs, and if there's RCDs, I also look at the fault currents, the short circuit currents with long lengths.
So what have people voted on that?
It's pretty split, really, because, again, we're kind of adding information as we've been talking through it. And Neil's been adding bits as we go through. So we've got a real mix. We've got 14 people, 37% have gone C3. Then the next one, 34% is FI. And that's because, again, there's lots to explore in that system, I expect.
I like the use of the limb.
11% limb. 13%.
Is that limb because of the extent of the inspector's knowledge, perhaps, maybe?
Well, no, the limb has to be agreed. So whoever's voted limb is assuming that whatever they've limbed is agreed. I'd like to, if you have said limb in the chat, please explain your reasons.
Yeah,
I'd like to understand where you're going with that.
Yeah.
It's good. That's a good balance. I like to see different people's thought processes on this. Right, we'll come back to that if somebody does explain. Now, here's another one for you. So this is just a really old switch room. It was feeding. What was it feeding? It was behind the London Underground station, but it was supplying not a chop shop. What do they call garage? So it was actually supplying a garage as well as some London Underground equipment. I think it's a work of art, to be honest with you, because it's old school.
Beautiful.
But what does everyone think? I mean, if you walked into that and approached it, what would your views be? Because I think that's a dying art, building stuff like that. All angle iron, mounted distribution boards, good old-fashioned buzz bars, fixed traflight labelling. It's old, yes. Some of them switch fuses will have asbestos rope in them. The blue boxes on the right are 110 volt distribution boards. They were for the gate lines because gate lines run on 110. The stuff on the left was distribution in the room and a supply to the garage. I keep calling them chop shops. I shouldn't really, but it's a nice old one. For me, I look at that, and I'll go first on this. For me, I look at that as it's approaching the end of its serviceable life, and the only reason I say that is probably because of the asbestos precautions we have to take. And at some point, I may not be able to get spares or components for it. So I might look to put in an investment to replace that. But as a code, it might be a C3 or an FI. Oh, I've done it again. But that's it. In time, I wouldn't bat too much of an eyelid on that. I wanted to shut that in.
What's your thinking on terms of? See, I can't see anything in there that would give me reason to code it. If I'm honest. Without going, obviously,
no, I mean, you're gonna go further into this, aren't you? But from just the immediate observation, there's obviously thinking maybe there's asbestos. Obviously, think about
the white square on the right is a block diagram. Most switch rooms that have been built with some vigor and accuracy will have a laminated drawing, which shows the electrical distribution on the wall. Make things easier.
See, I look at a photo like this. You've got drawn on the wall. Every switch fuse has got a label. Buzz bars labelled up. Distribution's labelled up. Every SWA coming out has got a label. I feel like it's been a well cared for installation.
You feel like kind of saving it and going to every other motherfucker out there. Come in here and see how it should be done.
Just to let you also know, by the way, that was ripped out 12 months later.
Yeah.
Yeah. And what they put in was crapper than what was ripped out.
Oh, no doubt.
There you go.
Yeah, I mean, obviously, you got to look further. There's risks of asbestos, but immediately there's nothing that I would go, ooh, there's nothing here that's.
I'm with you on that. I'd just like to say on the asbestos, if anyone is delving into the industrial, please do an asbestos awareness course, because you will come across it a lot more than you would do in commercial.
Oh, hang on a minute.
And
Mr. Skirm's bloody watching.
domestic.
Yeah.
It's 30 quid, 35 quid online,
and
you money well spent.
And ask for the register when you arrange to work with the
Mr.
client.
Skirm's made a valid point. Any asbestos C2, I think there is potential danger in it. Is asbestos in the scope of 7671 as a purist? No. But, again, that duty of care, the professional inspector, the indemnified inspector, there's definitely
it's a note for me. It's not code. It's a note.
There's an observation there, isn't there? There's an observation as a minimum to note to the client, without doubt.
The problem is, obviously, because we're doing the work strictly to the model of BS 7671, we then have to go to that. If you say it's potentially dangerous, yes. If you say which regulation, you go, which regulation would you say? And that's the problem.
You don't mind me saying, this is where industrial, we need to start thinking bigger picture on industrial, because you miss stuff on the industrial thing, industrial installations. There's more legislative obligation on the inspector as well. And I think there's more to observe on industrial than you would have within a contained house. I think that's fair to say, just through size of installation, applied use, environmental conditions, electromagnetic environment. There's just more to it.
Well, it's worth saying that asbestos is not automatically dangerous. It's if managed, can be managed perfectly safely. Yeah. That's why you have an asbestos register, so it can be managed safely. So that's worth thinking as well.
You do find with electrical systems, it's for a lot of asbestos assessors who do the marking. When it comes to electrical switchgear, they don't have that competence to take that out. So sometimes they go maybe. You get that a lot. You get a maybe, so you don't get a yes or a no. Sometimes you do, but sometimes you don't get enough information.
I grew up working on this stuff. I've worked on loads of these English electric switchgear stuff, and I at the time didn't know of the dangers of asbestos. To be honest with you, in fairness, when we were opening and closing, we didn't really disturb the asbestos rope, but we had this debate at London Underground many years ago, and their asbestos expert was, by opening and closing, you are applying pressure, you could release fibres, there is the risk. So it was ripped out on the basis of the fact there was asbestos content, not that the fact it was configured beautifully, maintained, well looked after, as irrelevant. Get rid of something that could become a court case.
I agree, and this is a really good point. So what Dave said about this sometimes being outside the scope of an asbestos register. So an asbestos register is for managing asbestos that you know is present. Generally speaking, if there's any intrusive works, that will not be within the asbestos register, and it's certainly you're not allowed to work underneath the asbestos register. If you're going to work in and around asbestos, then you need what's called an R&D survey of that asbestos to determine if it's what type it is, if it needs removing. So by the book, what I would do in a situation, I'd look at the asbestos register. If I opened up a panel and there's asbestos in there and that wasn't registered on that asbestos register, I would stop works. I would inform the client that an R&D survey needs to be carried out on all the panels that I'm working on. And depending on them results will be how we move forward. Yeah. That is the by the book procedure if you come across asbestos.
Your system of work has stopped. Because you're working within a system of work, and if you find asbestos where it wasn't anticipated, that's not in your system of work. So you can no longer work to your system of work. So you're right, Neil, you've got to full stop and step back away from that, and not obviously step around it.
So just on that, one of the chaps has said the only thing I would say is missing Adam Glover, insulated matting around the switchgear. You can actually see at the base of the picture there is insulated matting, although they weren't.
Stuff there.
Rich, do not trust ASI register. Be very sceptical. I agree with that completely.
You should not be working
are full
under
of caveats. Yes,
you should not be working under an asbestos register. That is just for managing asbestos, not for working under. It's really, really important that you know the difference between that.
Further information needed. What have you been asked to do in the room? This is just going in and doing an EICR, basically going and looking at the condition of it. Your safe system work must state you must stop works. Yeah, absolutely. This is put in for a reason to stimulate that debate on the old stuff is lovely and good, but there's potential asbestos. What do we do? Management controls, procedures. It's all part of the industrial type coding debate when you're going into bigger distribution setups. Right. What did everybody say? Did we?
We got 44% FI.
Okay.
34% C3.
I think that reflects the obviously what
You need to look into it further. Yeah, you need to get closer up to it all, don't you?
So this is a large industrial building. It was like a warehouse where they manufacture stuff, and I want everyone to look at the picture and see if they can spot in the chat just very quickly what they can see wrong with that picture. And then what I'll do is I'll give a little countdown and I'll zoom in. 3, 2, 1.
Need the countdown clock.
Yeah, sorry, we're not that advanced here. So what you've got is some luminaires that have been held up. So it's undergoing refurbishment, but during refurbishment, there is still a requirement to maintain site supplies, adequate illumination, etc. You've been brought in to do. So I was actually doing this EICR. Okay, so this was taken on a digital camera quite a few years ago, and I loved it because I thought, great, you've got the industrial fit in there, you've got, temporary supplies ain't great, you've got that jack chain to protect it, nice piece of unistrut, and a plastic tie wrap holding it up. Really defeats the object there. So I just thought, you know what, that's relevant nowadays because we always talk about premature collapse and the dangers of, and I just think that's a good one. So what would people code that if they saw that in a warehouse today?
Okay.
Are you specifically just talking about the cable tie holding the light?
The cable tie holding.
Not the rest of it, just that bit, right? Okay.
Well, you can go into the rest of it, but I thought I would highlight that bit because that was the bit that made me laugh.
No, I'm not even saying I can see anything else wrong. I just want to.
While people are doing this, so you're going to test the fixed installation, and if this is a temporary,
yes,
where would you still document it?
Yeah. So this building was undergoing a refurbishment for about 4 years. It was done in phases. So the site temporaries, by the time they'd finished the site temporaries, they were doing pat testing. Sorry, by the time they finished pat testing, they were going back and redoing it. And literally the EICR stuff was a never-ending ongoing because it was huge. It was massive, massive, massive industrial units. So by the time they'd finished, it took them a year to do the EICR on the site temps. And by the time they'd finished it, they were going back to the start and finding it all changed. So it was ever evolving.
David Betteridge in the chat has made a good point.
Yes.
Was these site temps under 3-month inspections?
Yes, they were. This was one of the things that I was actually brought in to do.
Right, so that would be, I would see 3 that based on that then. I would see 2 if it was not covered under 3 monthly inspections for site temps.
So what about
the 3 monthly inspections?
7375, is it, Dave?
7375.
Practice for construction site distribution, power supplies. Is there anything in there possibly we might want to read? Oh no, someone's going to go and buy a copy of it, aren't they?
Dave,
don't waste your time. There's only a bit on insulation monitoring, and good luck finding that. Yeah. So I just thought it was a good one. I thought it was just.
It's good.
Brutal irony, really, because the safety measures there was horrendous. I mean, when I say horrendous, I mean it was like 2 days of constant briefings on safe, and then you go in and go, well, that's evacuation route. There's a light fit in there. It's got a self-contained battery. It's all up on these steel chains, which is all money. It's all time, and then someone just puts it up with a tie wrap.
Yeah. That's a C3 if there are rigorous inspections are in place for me. Hang on a minute. Now I'm thinking, That's outside my scope of an ET&I if there is 3-month inspections on the... Are we coding this as the inspector of the site temps or as the inspector of the
That's
building?
where I was going.
Yes.
Are we coding this thinking like
Yes.
as a...
We are doing 3
Then it should be
monthly
suitable for the
EICRs.
temporary.
We
Right,
are
that's a
doing
C2
three,
for me then.
yeah,
That's
we are doing
C2.
C2 for
EICRs
me, yep.
because the risk profile is higher during the transition
During the work.
of the building. Yes.
That's changed it for me. If I was doing, that's C2 for me.
Yeah, same here.
That's
What does
right.
everyone say?
I agree with that. Let's just see the poll.
I thought it was a bit different to talk about premature collapse.
And can I just go back to chat before we move on to the next one as well, Paul?
Yep.
Okay, so that's C2, 59%, C3, 35%. It does create a questionable area. If you're doing a fixed installation, but there's temporary systems, you've got to find out where your line is in the sand with your client. Are you going to take this in? Because if you're doing it for the client to maintain operations of business, that is all possibly encompassed within that. And of course, if you may need to go to 7375, if you feel
And guess what? If you're the electrical contractor or the inspector that writes on the front 100% of installation
100%
covered,
then
you've just signed up to that. So it's really vital. I always get onto my guys about this. Write a story about the stuff you are inspecting, as much detail as you can, so there's no grey area about what you're doing and what you're not doing.
No, yeah, very, very, very important point. Okay, before we move on to the next one,
block between yellow and white flex. No, it was a plug and socket system.
referring back to the asbestos, Daniel's just mentioned here about 341.1. How does the asbestos impact maintainability? And he's copied and pasted here 341.1 general, and it just says an assessment should be made of the frequency and quality of maintenance the installation can reasonably be expected to receive during its intended life. The personal body responsible for the operation and on maintenance of the installation shall be consulted. And these characteristics are to be taken into account in applying for the requirements of parts 4 to 7. So have regard to the frequency and quality of maintenance expected, any periodic inspection, testing, maintenance, and repairs likely to be necessary during the intended life can be readily and safely carried out. So does the presence of asbestos compromise the ability for maintenance to be safely carried out?
Given the emerging knowledge of asbestos and hazards it creates, yes, it does. Now, when it was installed, it was safe. The fact of the matter is, once asbestos was raised as a national hazard, the client should have been aware in taking precautions to manage asbestos, including in its fixed installation, but exposing contractors, they would have to have X, Y, and Z control measures in. Maybe they haven't done that. The fact of the matter is, for me, if I was going into that room, straight away I'd be going, yeah, it's old, but it's fine. But the presence of asbestos straight away warrants some form of action and debate and discussion.
So we may not find there's an asbestos regulation, but we can look at what the asbestos creates, and that is a potential danger
the asbestos
for a maintenance
stuff is
activity.
the duty of care, and asking the client, how do you expect me to do this? How do you want me to maintain
Yeah, but
this?
we may want a regulation to put down.
Yeah, and I think that regulation is sound, but this is where we've got to start using our judgment. Now, generally speaking, and no one please quote this, because generally speaking, the asbestos you'll find in consumer units and distribution boards is non-licensed. So a lot of industrial electrical contractors can attend the one-day course and remove that because it's non-licensed.
That's right, because they tell you to just cut the cables and then bag it, don't they?
Exactly. So it's all about, you've got to think about these things and say, well, hang on, who's your maintenance contractor? Are they licensed to work with asbestos? Well, then that may well change it from a C2 to a C3 in that situation, because it can be maintained by their contractor. Sometimes
it can be done. It's finding that point of isolation to allow you to do that chop and removal. But I've done that one-day course, and there were a room full of electricians, and that was quite handy to know. Because for us, we'd all worked around it our whole life, so there was no fear of it. But the control measure we thought was quite good, the way it was explained to us, of find a further higher point of isolation, just cut, don't disturb, have double proprietary bags, etc., and remove accordingly. I thought that was quite smart. Yeah,
but it's all about that sort of judgment and start to think about, okay, what are the questions I've got to ask to code this appropriately to the best of my knowledge. Who's your maintainer? Are they licensed to work with this stuff? No. right, okay, that's going to change what I do as a C3 to a C2. Is the equipment looking like it's knackered? Is, you know, all these sort of things. There's so many different questions rather than just going, it's a C2.
Skipping on.
For me.
Exactly. That's the point. You can't just say it's that, can we?
Let's do some quick and dirties. So
Yes.
here's armoured on a tray. It's medium duty return flange, and as you can, hopefully you can see here on the picture, the armoured has burst through the sheath of the cable. And that's one you will find on many an industrial installation.
I know it's
How would you
inevitable
code that?
sometimes, but I do hate it when armours show all of these scuff marks and things along.
It's awful. I
Can't avoid it, I know. but-
I make sure they're wiped down and clean.
Yeah.
I can't stand that. It's disgusting.
All right.
What does
Okay.
everyone think? Put the poll up.
Boom.
So,
So
I'm gonna
what's
start
happened in
with
this picture?
So basically, you've got two armoureds, two
Yep.
sub-main armoureds. The one on the right, where my mouse is, you can see that the armouring has split, and you can actually see the ribbing of the steel exposed. It's just me with my ridiculous hawk eyesight there. I've zoomed in as much as I could on the photo.
So has the
without
armour
ruining it.
been damaged?
Yes, it's burst effectively. It's been damaged. It's ripped the sheath off, and you can see where the armouring is. So
But it's
That
actually been
outside
physically
insulation.
broken, the armour.
no, the armoured's fine. It's the
Okay.
sheathing on the outside of the armour which has been damaged to expose
Okay.
the armouring underneath.
This is indoors.
Yes, in a switch room.
In a switch room.
What would you code it? Now, remember, just considering how expensive it is to run armoureds, and I think that was a 35mm 4-core at the time. What would we code it? I'm just interested to see what the code. For me, it would be a C3. However, knowing what I know now, you could argue that the life of that armoured has been compromised, because obviously you've compromised the outer sheath, which means if the armouring was being used as a CPC, it could compromise the integrity of that over time, because it could prematurely corrode.
Is the armour being used as a CPC? Is there
For
presence?
that one, no, because if you look to the left, separate
Yeah.
CPCs were run with the armouring. So this is
Okay.
mechanical protection only.
Okay.
I
and
would be
it's-
looking at, so that, yeah, if it was a CPC, I'll be looking at, is the minimum cross-sectional area okay to be used as not mechanically protected CPC? If it was okay to be used as non-mechanically protected CPC, it's C3, poor workmanship.
So the tray work's all bonded, everybody, by the way. The tray
It's a
work
C-
is bonded.
It's a C3. I can't see anything
Yeah.
potentially dangerous about that
C3 with a
installation
zip
at
kit
all.
needed, really, isn't it?
Yeah. I'm asking questions to see if I can get a C2 potentially out of it.
Yeah,
but
yeah.
that's- Nothing's biting.
It's a C3, and then find out where the electrical installation certificate is and whose name's on it, and go, what the hell have you done here?
I'll tell you now, though, if the CPC was, if the armouring was the CPC, I'd be C2ing that, and I'd be not very happy.
What would
about
it be? Why would it be that you're seeing to? What would you say is potentially shortening its life?
Because I've designed that armouring for, say, 30, 40 years, and eventually there could be potential corrosion on that armoured.
Right, so you're saying corrosion.
The impedance, yes, corrosion.
So are you intending on not inspecting your installation for the next 40
Well,
years?
Potentially, yeah, because I could be a bastard client. Aha!
That's not. I would see to it only, and this. Do you know what? I'm really struggling with a C2 on this. I would see to it only if the CSA required it to be mechanically protected, if it's a CPC, and even then, I'm pushing it a bit. I mean,
Yeah, stretching really.
yeah,
I'm stretching.
really
I'm trying to
pushing
get the debate going. That's why I'm
Reaching.
stretching it. I'm stretching it for a reason.
Yeah,
Right.
yeah. That's fun.
Let's move on, because we've got some crackers coming.
All right. Well, let's just quickly see what we got there. We got 75% C3.
it.
Great.
You would be right. Use 75%.
Yes, absolutely.
So-
And well done,
the
the others.
C2 13%. Obviously, we're a little bit more creative
So
than we
I
were.
thought this would be good. So this was in a warehouse, and
Wow.
basically there's a ducting system that goes underneath the warehouse, and this was a reasonably new electrical installation, as you can tell. And some genius decided to create a diving platform for bugs and mice so they could come out of the swimming water. None of the cables are duct rated. As you can probably tell, that armored isn't. The armored and the box isn't IP rated. This was when we lifted up to find a fault, and we literally just found that.
I love the amount of good workmanship has gone into that naff up. You've got it spaced off the wall with Unistrut, 41 by 41 Unistrut. You've got fixed base connectors, perfectly straight, gutter bolts.
Yep.
There's so much good workmanship gone into that. I don't want to code it, but
Someone's used it as a joint in box rather than a Scotch joint or a resin joint or whatever word we're using for it.
Do you know what? This is really a good example of
found
how things can happen like this. If that's gone down and done vital equipment in an industrial setting, that maintenance spark has had to get that up and running as quick as possible.
Yep.
All right. So this could well happen. Very, very, very common. So
it could. You are absolutely right. It could be get it fixed, get it on, get it done. Nobody, when they lift up, the trouble is what it turns out is these ducts, when they did the civils work building this estate, the outside drainage and the inside drainage, there was a little bit of a washback. So it turned out all of the ducts were filling with water, especially when it rained heavy.
So that could be underwater soon.
Yeah.
Yeah.
This was pretty new, in all fairness, to be honest with you. This was something we found.
It's a C2, isn't it? It's a C2 all day long.
Yeah.
It is, and it has a big concrete chamber on it.
What
does everyone think? We'll do the poll.
One question was the lid already off?
Yes, it was.
Oh, wow, okay.
Yeah, it was. Yeah, lid was off.
Oh, okay. Oh, that changed it then. Hang on,
Lid
I
was
need to
off.
get rid of that coding box. And what's the... So we've got... and the access patch to the ducts, is that needed a tool to get into it?
Yeah, it needed a lifting device to lift it. It was a massive
keys.
chamber. A little bit more than keys. You needed one of those little wheelie things. It was a big, heavy,
The
standard.
the really big drivable ones.
Yeah, it was a big one.
I would go C2 then. But there's a floating neutral, is there? Is there a blue?
Yeah, what it was
there?
there was a flex connected into the top there because somebody had wired or evidently had tapped into that circuit, and that cable had basically came up and was coiled up and was just, I haven't got it in the photo, but it was basically just coiled up. So somebody at some point when they did that joint nicked, and this is what I love about industrial, nicked a supply for something that they needed temporarily and just left it. They disconnected from there, just put the cover back and left it.
I reckon that
You
was...
find these things in industrial.
That joint box was put in there specifically for that tap off. Yeah, for me, that's a C2 based on that, but I wouldn't fall out of a C1 on that.
Yep. Okay.
Yep. Okay.
Yeah, we've got 75% C2, 25% C1.
Do you know what? A good wrist treatment there? Sump pump. Drill a hole, get a sump pump wired into it, get a control system.
Yeah,
But mitigate the drainage.
They got supply for it. They can also follow.
Supply for it.
We had this race course that I used to work at where we had these 63 and 125 amp three-phase sockets in pits, and the sump pump failed, and they were all underwater at some period of time. And then just before their annual season meeting, I had to go in there and just get in the pits and test them and clean them all up. So sump pumps.
Okay, Dave. This one is one of yours, and this is based on recent debates on social media. So
This is what do you mean? You started this debate?
I didn't.
I just made a nonsense YouTube video months ago.
You made a nonsense YouTube video.
Okay, so I noticed when I was doing some, I can't remember what it was I was doing, but I was doing some research on something, and I found a Hager document that talked about MCBs, RCBOs, and it said that if you have them spaced side by side, then there's a derating factor from their nominal rating. And I put a video on that. There's rating factors for frequency, there's rating factors for spacing, and there's rating factors for ambient temperature, all derating the nominal rating of the device. And over time, we've kind of gone back to that, and we've been thinking about that. And then you said on Instagram the other day, oh, you know, if you've got loads of breakers, you want to think about spacing them out a little bit, if possible. And you got a bit of a response, didn't you, Paul?
A kickback is an understatement. It was a suggestive idea based on, yes. So the breakers that we looked at in your video were designed to operate normally at 30 degrees. Plus and minus could affect the tripping characteristics of the breaker, i.e. heat affecting the bimetallic strip within the MCB would make it more sensitive to any thermal event. Henceforth, if you had a breaker installed at, say, 40 degrees and it's a 32 amp, it may trip at 30.
And so it's the same principle as cable grouping. And we weren't saying you must now space them. What we're saying is if you have them all bunched together, let's say I've got a nice stacked three-phase board and I've got 6 32s and I'm running them at fairly large demand, nearly full rated demand. Let's say that they're door curtains or some shit. Then they aren't going to be rated at 32 by the manufacturer anymore. They're going to be rated lower.
So are we saying that a manufacturer is saying that to install them side by side in their consumer unit or their distribution board may affect their operation under the top 25%, for example, of their current rating.
Yeah, if you run them both side by side at full load, so they're heating to their rated amps, then they are going to be giving off temperature, which will then affect its next door neighbor if they want to reach the same temperature, because they can't give off temperature together. If one's off, then the other one's on, then one's off. That's fine.
And the
you have
one
them all under this different period of demands.
The one observation we've made is with these electronics that are going into breakers now, AFDDs, smaller RCPOs, they are producing more.
They're always warm.
Far more hot than what we would have a double pole, Crabtree RCD. The RCPOs now, the single versions, the smaller compact ones, they produce more heat. So again, it's that mutual interference, it's that thermal effects generated within the installation. It's proportionate to load, proportionate to ambient temperature. So we put a picture on Instagram just to get people kind of reminding them to think about the external influences and the conditions, and how modern electronics are now maybe need to be a little bit more considered, because we are talking about with type A RCDs and type B and connected load. So it was just,
and we're not saying you must code this, you mustn't do that. We're saying obviously we need to make sure we follow the manufacturer's instructions. We might not be aware of what those instructions are actually saying.
Yes, because they don't put it in the goddamn boxes.
No,
that's the problem. They hide it online.
They hide it in
Hager. Hager put this online. It wasn't us that put it online. It was bloody Hager. You go to Hager and ask him, they'll go, yeah, you're right.
So on top of that, if we go back to the industry we're in industrial, I'm looking at selectivity. I'm also, what BS number are them breakers?
They're most likely
62898.
Yeah, 628.
Yeah, 62898 and 61008. And there's a reason why that's there. Shazam.
So I'm thinking
the conversation piece.
60947 should be the breakers we're using in an industrial setting.
Yeah, that's a good point. We'll come back to that one.
We will.
So the reason you put this in, Paul, really is to highlight these two breakers, these two MCBs that you can see are pulling the load. They're not hot. They're on. Yeah, they look warm, but the maximum temperature is 30 degrees. These are just on. But you can see, if you actually go to the next one where you've got a higher contrast, you can see these two breakers are giving off a temperature which is now being absorbed into the adjacent devices. Can you see that? Yeah. So the standard temperature of the conductor under no load is being increased slightly by its neighbor. That will start to derate its capacity.
So the question is, and are them breakers designed with that in mind?
These are Crabtree. We haven't gone back to specifically look at these ones, but the Hager ones that we did, and I think
Hager acknowledged this.
JW posted another company that's done it. I don't know who it was, but another company's done this. But it's just a common thing under 60898 and 60947. Similarly, like the ranges that the connections can reach. These connections, these metals in the terminals can go up to 70 degree Kelvin above ambient.
Yeah,
that's fine.
No, it's also worth noting, if you buy a time switch in industrial, a contactor or a time clock, in the manufacturing instructions there, they actually tell you to space it from others. And yet, Neil, you and I have both been to railway stations where they've got banks of them. There's no spacing at all, and they are kicking off heat.
I took some thermal images.
Compatibility from a thermal perspective.
I took thermal images of boards with contactors where they were spaced apart with an air gap of one in between, and they were fine. Then I'd take some where they're all together, and you can clearly see that there is a impact. This is more the RCBO thing that Paul was talking about.
Yeah. So this is an industrial board, as we'll recognise it. It's a Schneider Isobar P board. Sorry about it. I just wanted to show the context of there's trunking above and below it, and then obviously a little bit more zoomed in. But if we then go to the thermal, some nice thermal images there that just show that under load, and you can see at maximum is 42 degrees.
And these are under negligible load.
Yeah.
Electrical load. You look at the mains, there's not a lot being pulled here.
Yeah.
Yeah. It's actually all this load. The heat sharing, and then you've got dual heating onto the conductors, which is giving a little bit of a pattern onto the actual conductor itself from the device. So all this heat is coming from the devices themselves. Yeah.
But generally, I'm not sure how you see this, Dave. So when would you, what sort of, is there a rule of thumb? I mean, we work to 20 degrees above ambient. If there is a rise in 20 degrees above ambient, then we will report that back. Is there any sort of guidance where you sit on that?
It's just pretty much fair. I mean, some companies will do, we go with a standard and then we go to X amount above. What I do is I will obviously look at the cable type. I understand the cable's limiting temperature, and if I have a cable go over that, I'll have an alarm on my thermal camera, which will then go over that. In this scenario, there may be lots of circuits, but many of those circuits are probably pulling barely a couple of amp at a time, and I need to know that. And then find the cables that are pulling larger demands and identify where they are. And if any of those are pulling demands at the same time, and if they're close together, can we reposition them in the board? That's the key. It's understanding what's on for how long and its demand. And then we'll actually see the proper patterns. This board has pretty much about 3 or 4 amps pulling on it. It was not a lot on. There's only a few amps, maybe 7 amps at the time. You've gone quiet, Paul. He's still quiet. He's muted himself.
Swearing at someone.
Yeah.
Sorry, I muted myself. Apologies. Yeah. Just going into the chat, Mark Holmes has asked a question. Does it go the other way around where the DB is a cooler seller? So if I use the Hager information, what I've got in front of me, so at 30 degrees, let's say a 10 amp breaker will trip at 10 amp at 30 degrees. If we go to a cooled seller, a 10 amp breaker at say 10 degrees C will not trip until 11.6 amps. Has gone through it. If I then go to 40 degrees, a 10 amp breaker will trip at 9.2 amps.
The thing is what I touched on earlier with the different standards. If in a cooled cellar, I would very much like to think that 60898 is not the appropriate breaker to be installed inside a cooled cellar. So
we're going to cover this more. Because this all falls under pollution degrees, and pollution degrees is got to do with thermal and magnetic environments, and there's some very good papers on this, and Schneider have been industry leading on this, but I think this is a very emerging, well, no, not emerging, I think it's just a very unknown. How many people look at fires in boards and melted breakers and link it back to well, there was all these electronics and the ambient temperature was, and this was happening and the loading patterns was this. It's normally after the event. I think there's a lot of stuff. So what we were trying to do is stimulate a debate, because I said this, I've said this to my contractors as well. We're not taught this stuff in college. We're not. And unless we really start pounding on the manufacturer's door and say, give me your thermal characteristics of your devices, we'll never know. Now, I've been asking CP Fusebox for their data, which is why I put that picture up, to stimulate the debate. Not to say you must, you will, you shall, but based on that thermal profile, I would probably look at every 2 or 3 breakers creating an air gap just to allow that heat to dissipate. Why? Because if you look at the manufacturer's instructions for time clocks and lighting contactors, they require an air gap to allow that heat, that thermal load to dissipate.
The fact that they're just RCBOs for me, and the fact that they're within 20 degrees of the ambient, I personally would not highlight this. I know the thing is with this thermal imaging, and you've done this very well, Dave, on your webinars, you need to look at the thermometer scale, the temperature scale, because they can look really like, wow, my God, look how bad
they look hot, but they're not.
But when you look at that, it's not even 20 degrees above ambient. For me, I would not highlight that personally.
This is only a problem if I've got circuits that are designed to run right at the rating of the overcurrent device. If I've got a circuit and let's say that I've got a circuit that's going to pull 19 amp or so, and I put it on a 20 amp and I've put it between, it might be that device, the thermal cutout on that device has been handicapped by its neighbors if they're also warm under load.
Yeah.
That's where we're going with this one.
And this kind of addresses, it's kind of touched in the regs, the compatibility of characteristics, and the pollution categories. We as an industry are not emerging our knowledge sufficiently. And we're on this journey, which is why we're openly talking about it here, because there's no wrong answer at the end of the day. There's only stupid questions. And I think this one is something that I'm kind of excited actually to start developing and understanding more as we go along.
This caught me out because when I found it, I was like, okay. Then I looked at the fact that why haven't I been told this? And then I thought, okay, well, designers are supposed to know this because it's design data, it's manufacturer data. So it's just one of those things that we just haven't discussed.
This was a chat point. Well, this isn't a codable issue at the moment. This is just something we thought we'd address in this because it, especially in industrial large distribution, Neil, we thought it was very prevalent as well. Here's one. I think this was Eddie's. I think Eddie's in here. So this was sent to us by Eddie Clements. This is definitely
Eddie. There he is.
Some sorts. It looks like a good old-fashioned three-phase distribution panel. I bet when that was put in, that was lovingly put in. Well, yeah, okay. So if we look at the old fuse carriers, I'm assuming they are rewirables. So I've put this across 2 pages because there was quite a few photos. But you can see there's a risk straight away. You've got a broken fuse holders. You've obviously got a non-appropriate fuse wire in there.
4,000 amp fuse wire.
Yeah, I'd say it's about 1262.
But things like this, just a C2, because we have to have a fault for it to be a problem.
If Eddie wants to shine any more light on that quickly, he can do. But for me, I'm kind of C2ing that really because it's just
based on what we're looking at now, C2. But other things I'll be looking at on this, again, considering where we're testing, I'll be looking at single point of isolation. There's no isolation. What equipment is this feeding?
Safe system
is it equipment that needs to be shut down quickly in the event of a fault, an emergency? That sort of things. These are the sort of things I'm looking at when I look at that. There's no single point of isolation. There's many other things that I'm looking at.
Eddie can't remember this one. I'm C2ing it, but yeah, my biggest concern is safe working practice.
Is there not an isolator prior to this panel? Do you think?
Doesn't look like it.
Because then I'm thinking, because the problem with that is obviously you're filling fuses under load. There's obviously, I'm thinking about, there's an arc flash risk as well there.
Well, that looks like it's been done a few times, that one. If you look at the bottom pins, that's definitely been put in and out.
Yeah, you can see on the blades, you can see that's been put in and out under load. You can see the yellow tape around the fuse carriers that are just falling apart.
Wonderful.
Yeah, it's certainly needs...
C2.
Yeah, C2, isn't it? What does everyone say?
C2, 88%.
Excellent.
Yeah, good. Great. Cracking. 88%. Well done. Right, moving on. This was another one sent in by Mr. Burke. This was in a industrial warehouse. Geez, I mean, where do you start? There's so much in one photo. So much in one photo. Armoured, cleated, removed.
Full workmanship.
Use of foam filler. Is there compartmentation there? Twin and earth just hanging. Strain upon conductors. Dorman Smith boards. Can we see 2 then? I'm only joking. But yeah, there's a lot going on there. Cables entering the board. It doesn't look like there's any real protection there from what I could see. I think it's quite an interesting one. You've got some cables coiled up here.
There's no fixings on the armor coming in. The bending radius looks a bit mean for that. There's be a lot of pressure on that. This is one of those things where you're just going to go, oh, there's a C3, there's a C3, there's lots to see here, and there's a few, so
it's a lot.
It's one of those things. It's like on the face of it, I look at it as C3, but then I think if that's just clean the store, if that's a store code, I'm then aiming towards a C2 based on just the poor droop of cables there that could easily be stacked upon and not protected. I'm looking at mechanical protection. There's lack of mechanical protection depending on the use of the room. So I'm C3, but I could argue C2.
I agree.
On the use.
I'm going to go with C2. I'd argue C2 on that.
It's a C3 unless I know some other things such as the use or the risk or
well, for me the lack of
collapse as well
on the twin and earth alone is enough for me, to be honest with you. That's just enough for me because again, it's the application and the use, but the foam filler is just a disgrace. That PU foam should be banned. It's an awful tool used by labourers to just make their problems go away and make sparks last hell.
Okay, so we've got a 70-30. We've got 70% C2.
Okay.
Oh, it's just changed to 68% C2 and 32% C3.
Yeah, I'd have a debate. Write a small novel on that on a C2, I think.
Yeah, no, that's one that I would probably end up filling a few codes with.
Indeed.
But this is a typical example of when an inspector needs to ask more questions.
Indeed.
And needs to understand, right, what's the use of this room? What's the control of this room? You covered this last week. Who's got access? Where is it? You know, all these sort of things matter in this instant, it's important because the difference between a C3 and a C2 is quite significant. So it's important that them questions are addressed.
So trunking on a gantry. As you can probably see, these next photos are going to kind of delve into something which industrial is very, very, it's not discussed enough on industrial, and that is selection and erection suitable for the environmental conditions. This one you can see straight away, there's a cable management system. By the way, all those cables are live, and because I took them photos, it's pure corrosion. Pure corrosion. I believe that was in oh Christ, it was somewhere near the Tate and Lyle factory actually in East London, and it was a workers' gantry outside. But as you can see, it's pretty pants. I don't actually have another. You what?
Mr. Skirm's leaving. He's off.
Oh, sorry. Sugar, indeed. C2 for me. I mean, I find it ingenious that they've actually painted over the single core cables under this gantry.
There's an immediate
painted
problem
over
there,
the rust.
because you'll have some places that will go, oh, you know, placed out of reach, it's not a problem up there. But there's evidence there that another contractor has been in immediate potential danger, and whoever's authorised that work hasn't assessed risk during the work.
Oh.
For a painter to come along with a brush and paint exposed cables,
yeah.
So, you know,
well, you can see where it's just flaked and flaked and flaked, and then the vibration of people walking across the gantry has just made it slowly break and break and break and break. It's actually insane, because the electrical contractor was actually prepared just to replace the lidding of the trunking.
Again, as Neil said earlier on, you've got you know, this is near the water then, isn't it? So you've got you've got rust. So you've got to change your wiring system, haven't you? You've got to strip it out and start again.
It's just C2 all day long. But let's think about this. You know, electrical contractor can only go by what the funds of the client's given him. And now if he goes back and says that you need to replace all your trunking, and the client says sorry, then it may well be that they've only got the funds.
But that's irrelevant to the EICR. Or just taking back from the coding. I agree with you, because you want to fix it, because you see that and you go, that needs to be fixed, period. What's the budget, etc. And you're absolutely right. But purist coding, I agree with you. It's a C2. There's too much danger in that.
I've got a question.
Yes.
So you've done that. You've C2'd it. Another contractor's gone back and replaced that for exactly the same material, galvanised trunking. You go back in 5 years. It's perfectly good, but you know the history. Do you code it?
I can answer that. But can I answer that in a bit? Because we're now going to go on a little journey about corrosion and external influences. So,
it's a great question, though.
Yeah, what was the answer on that one, Dave? Was it C?
97% C2.
Great. Legends.
Right, this is a quick one.
C1.
This is a quick one. What's wrong in this picture? This is a quick one. This is just to sharpen the pencil very quickly. What's wrong with this picture? Because when I first saw that, I was just like, hang on a minute, what? And this was a newly wired a back of house area in a large manufacturing plant, and I thought to myself, there's something doesn't read right there. Now, by the way, yes, this is recently taken, so if I'm going to give you all a clue, colour.
Well, I don't know the answer to this, but
it's single phase circuits. What colour are the cables?
Phase colours. Old phase colours.
Brand new. This is brand new.
Yeah, so you got red.
Green and yellow, blue and red. What they'd done is they'd actually said, we can't get any brown cables. So they said, so that we'll just get loads of drums of red and chucked it in.
Where are they getting the red from? Gee.
They had it sitting in their garages.
Oh, right.
literally like sorry, we got about 20 drums of red single core. We'll just chuck that in. And that was done recently.
Before we code, then, so what's the reason for the exposed ends?
Oh, it was being tested.
Right, okay. So we're in the process of testing it. So
it was being tested. I was actually walking around while they were doing the works, and it was being tested. And I looked at it, I went, I did a double take, and I was just like,
I'm going to relaunch the poll, because some people have gone in with a C1, and I reckon that's before Neil asked that question.
Oh, yeah, it would be a C1 if that was the thing. Yeah, relaunch the poll.
Well, I'm going
Apologies.
C3. Yeah, I mean,
Yeah,
assu-
I think
assuming they've used the colours correctly to the old colours. They're using blues
it
for
would have been red
lights.
and black. It would have been red and black, and this is recent.
Yeah.
It's just a complete mix-up on the fact that they could get rid of some old cables.
Is
C3
alphanumeric marking also being used?
Not on this one, but no. If you look in the background on my mouses, you can see brown and blue.
Yeah, because
Literally, they did run out.
I've seen many installations where they've got they use a multi-core like a 4-core armor, then they'll use 2 circuits in one, and they'll keep one of the phases would be yellow, and the other neutral would be grey or whatever.
No,
the regulations are okay as long as you use color and or number. So if they've used numbers here, alphanumeric numbering,
no,
then there's no problem.
No, this is just we've run out of brown. Get some red in and chuck it.
Then it's just non-compliant
C3.
BS7671.
Yeah.
It's a C3.
Yeah, and
Mind you?
just to let you all know, by the way, they were told to rip it all out and start again. But I thought it was a very good educational because I've shown this to a lot of Sparks, and a lot of Sparks have gone, So it's a good one just to get the grey matter going. Check the colour. Ask the questions. He's very deliberate.
Was this your work? Was it?
This was not a work. No, this was someone I was helping.
Right.
Going out to visit them for a day.
So when you said they were told to rip it all out, was that?
Well, I ended up going to the Tottenham Stadium, and look what happened there. But anyway, that's another story for another day.
Okay.
Right, moving on. This is on one of my jobs. Again, this is a colour one. So this is a Sorel box mounted to a wall. There's a transformer there. You've got brown and blue in single phase into the transformer. You've got these wonderful. I don't know what the colour is. It purple or violet or
Purple,
whatever we call it.
We'll just go purple.
What would your observations be? Would you code it? Now, obviously, the lid was on before anybody asks, so it was behind a barrier. But I just found this quite an interesting little setup. And again, this was actually in a railway depot. So this was a heavy industrial railway depot. Okay, so this was DC traction, open buzz bars, cranes, all sorts of heavy industrial stuff. But
isn't violet one of the colours we can use for control circuits?
Yes, it is. It is. It was actually being used for, I think it was used for 110 volt, if I remember rightly, because we traced it out to a socket. It was being used for 110 volt, which was why I was a bit miffed by the violet. But yeah, you're right, because you can wire, is it Felv or Selv or whatever it is in purple? I can't remember now off the top of my head. But there is a colour you can use.
Yeah.
What is it? Violet, possible ELV, yes. Looks pink to me, not even red. Paul, yeah, your eyes are as good as mine then.
So the guys.
I'm using old colours. Black cables looks sketchy.
Well, based on the colours being correct, because I don't know that off the top of my head, no code. But there's possibly for C2 just a bit of heat dissipation from the transformer and the cables there.
You know what I put this as? When I had a look at it, I put it as an FI. I wanted to know more. That was my first. I need to understand this weird setup. Is this a proprietary product, or has this just been made ad hoc on site?
But is your lack of understanding of the colours a legitimate reason to put an FI to a client? Based on you've priced this job, you've awarded this job, you know where you're going.
Yeah, but remember, so just remember,
FI?
I am, and it's a good point, I am inspecting to the wiring regulations. If I see something that I can't see fits within the scope of 7671 that has been built on site, then I would ask the client more questions. I'd look for further investigation. I may not have the time because I'm doing sampling. And this is
Daniel's dug into the regs. Control circuits, ELV, and other applications, line conductors can be violet.
They can be violet. This was actually feeding a 110 volt socket at the end of a pit, which was
that's reduced low voltage.
Yes.
Not extra low voltage.
Yes.
So does that classify?
See, for me, further investigation is, I know there's a problem. I don't know the reason for that problem. That is what I would use. I wouldn't use a further investigation to say, I know there's a problem. Or hang on, no, take it back. I wouldn't use further investigation to say, I'm not sure if there's a problem. As an inspector, we should know there's a problem. this is the basis, but I'm not quite sure why that is. Could be an open ring circuit, could be, you know what I mean? There's lots of things you go, I know that's not right.
Yeah, I definitely wouldn't kind of delay on this kind of thing. It's just what it is to me. It looks fine. There's the red tape. Is that a polarity indication or just a bit of red tape?
Bit of red tape.
Bit of red tape, okay. So maybe a
Definitely
polarity
a weird
indication would be good. But yeah,
It was definitely a weird one. It was kind of weird because the socket was actually down about 4 meters away to the right. It went into a bit of trunking and then came out and then went down. I mean, it was just something that we didn't see that was the norm. It's something that had obviously been bespoke over time.
Well, this kind of, like we had earlier on where we had the ELV with the other switch, this kind of splits us up here. And we've got 46% have gone C3.
Yep.
39% have gone FI.
Yep.
7% have gone C2 and 4% have gone C1. And a lot of people just haven't worked or got to use this.
And that again takes us back to the start where when you're working on that industrial, that larger stuff and you're going outside of your comfort zone, you will see unique bespoke stuff that may not sit within the norms of LV distribution submain. And I thought I'd throw a few photos in to just stimulate, look, this is different. We may not have seen it like this. Which again is a good thing to debate because it's then sharpening that pencil of how do I understand that a little bit more.
Yeah.
And that's why I threw that in because that one threw me. When I first saw that, it threw me.
Those are the things that kind of, but those are good because those are things that make you realize actually, you know, you have to stop a minute, reassess your understanding. You've got to rejudge your competence. Things like that are good.
And it's also the reason why you need to have access to a full suite of standards.
Exactly.
Because you will come across these sort of things and go, right, okay, I'm going to go away tonight and ruin my night trying to find it.
So, right, let's go into another series now. So this is one that is mind blowing. Okay, so Neil, what you discussed earlier on about something's gone wrong and we've replaced it, and you know it's only going to last 5 years. Okay. So here is the debut of the 5-year installation. So this is an installation that was put in which lasted 5 years. Just over actually, about 5.5.
So is this a refit of what was there before?
No, this is a brand new installation, spanking new installation, which lasted 5 years, which is mind blowing in itself. So as you can see here, you've got trunking, you've got some beautiful stainless Copex, which took all of the feeds out of the plant area and up to the distribution. You've then got the new armoreds all labeled up, so it's a reasonably nice job. But you have this severe attack of corrosion across the installation. Now, there's more than one photo before we even start running this poll. Inside one of the boxes, the reason we were there, we found this: burnt out cables. Okay, you see nice bit of labeling there and ferrulin and all that good stuff. So some pride was put into it. It was a neat enough job. But when we started touching the boxes, you can see they just fell apart from corrosion. See the glands, plastic, completely uncorroded, cabling, fine, no problem whatsoever. But each box, as you could see, just couldn't stand the test of time at all. Now, this was a 5-year-old install. That had burnt out, and the persons who found the burnout were incredibly embarrassed over the fact it was 5 years, and they did not want to tell the client.
I bet.
Because they were responsible for the selection and erection of materials.
Oh, so the people who put it in.
Yes.
And was it under warranty and all that?
Oh, it was out of warranty. It's only going to get 12 months.
This is fundamentally a designer's issue, isn't it? The designer made a
poor selection and erection. Absolutely. Materials suitable for their intended use.
This is so unique. No. I don't think I've ever seen that before. So under that time frame.
Oh, I've seen some corrosion, but I've not seen this excess. No way.
For me, if I come across this, it's definitely a C2, but I would go into more detail in my feedback to the client on this. So you really need to look at what you're speccing. I know this is only 5 years old, but you know we need to have a chat away from this report, and you really need to look at how. The people who's giving you advice on this equipment, because this should not be the case after 5 years.
This was a cause of one of the root causes. This was the cut and paste culture of industrial designing. I've always done it here. I've always done it this way. I've got a generic design that I can just whip out and keep fobbing off with the client. I'm going to read out to you just before you code it. Appendix 5, AF2, the presence of corrosive or polluting substances of atmospheric origin is significant. Installations situated by the sea or near industrial zones producing serious atmospheric pollution, such as chemical works, cement works. This type of pollution arises especially in the production of abrasive, insulating or conductive dusts. And it even talks about the nature of substances in accordance with satisfaction of the salt mist test, according to BSEN 60068-2-11. I've read it. It's yeah, painful. But yeah, basically what the cause of that was efflorescence, a combination of efflorescence, salt mist deposits from coastal areas, and the fact it was in the middle of a heavy industrial area. But that was 5 years. That
Was stainless the solution?
Stainless was the only solution there, and everywhere that wasn't falling apart was stainless 316. It's the only thing you can do. There is actually a Network Rail standard that actually covers this as well. But
Andy Foster said something interesting. I'm going to disagree with him, but he says it has emergency lighting from the middle one there. You can see platform emergency lighting.
Yep.
So for him, it's a C1. Now, that's not a C1 for me because something else has to happen before there's an issue. So this is an exact answer as we started off the webinar. In normal use, there's not going to be an emergency, so there's no problem. Something has to happen for the emergency lights to kick in, for the evacuation procedures to happen. That's the difference between a C1 and a C2 in my book.
Yeah.
Just to be clear, look at the labelling: emergency light.
I would say that
emergency lighting.
I would say this is where it comes to the point that we said at the beginning of this, where we focus on BS 7671, but we also need to think if there is emergency lighting that's not working, we need to have some ability to reference 5266 and other standards that actually give ammunition to the argument of emergency lighting and the integrity of it.
So what I'll probably do, and I'll probably get shot for it, but who cares? So this was actually at King George V station on the DLR, which is surrounded by houses and surrounded by heavy industrial plant. So imagine if that's the case, what else you can do by portally selecting and erecting. And that station was 5 years old when this happened. 5 years old. So it's worth considering these sorts of things.
Very poor design. So
what's everyone said?
88% C2.
Well done, 88%. Good on you.
I would agree with that. It's
fair play to everyone else.
Yeah, it would. I would add extra information about the importance of the emergency lighting and the need for it to not fail, but doesn't mean it's immediately dangerous. As Neil says, you do need to have the need for emergency lighting.
The annoying thing is,
you could, for example, that emergency lighting could be an area of a car park. You could just shut down that car park for a period of time. You know,
yeah, I mean, this actually did the platform lighting. So from an operational disruption, you're shutting a station, which is costing you tens of thousands of pounds an hour. It's costing you a lot of money. But yeah, so I thought it was a great example of external influences, poor design, and let's be honest about it. And I do asset management. It's the asset life. You're getting no value because the contractor doesn't want to use stainless. He wants to go galv because everyone in the sun doesn't like using stainless, or they're not used to doing it. So you don't get the 20-year life. You don't get a 5-year life. And this is a well-documented incident. So I agree with C2. Now we're going to go on to the last one because this is a short one tonight. And I'm going to show you that image there. So what can everybody see on that image? Can you see that image clearly enough?
3.2 amps AC.
3.2 amps. So this is the bit where I say thank you very much, everybody, for kind of taking part and tuning in. And we're going to be doing more of these. And we're going to do some on the DNOs. But I want to leave you with a final thought. And the final thought is this. So that's zoomed in on that picture. So everybody in the chat, if you can see what's going on there, you can see the DNO. So there's a TNS, by the looks of it, separate CPC coming along with the cable. Even says it on the label, TNS supply. You then have a 3-phase intake. Please note the lack of fuses. So that installation is completely isolated electrically, and yet you still have 3.2 amps.
So that installation is not generating any leakage current?
No, none. And the reason I put it up there is because we are going to go into this in future webinars. We're going to do one on coding of DNO intakes and how to identify them, and we're also going to look at this neutral diverted current issue in a little bit more depth. This is one of the reasons why I've been banging on about getting clamp meters and checking. If you want to prove if you have diverted neutral current, that is the test. If you only have one single source of supply, pull the fuses or get the main isolator switched off if you have a main isolator, and put your clamp meter on. If you have something, then you have energy being transferred into your installation. You may not have much voltage behind it, but you still have energy. And when you have levels of energy that go exceedingly high, then you go into the realm of arc flash, and there are hazards behind that. So that's really it, really. And I just wanted to thank everyone. And if anyone's got any question, and Neil, thank you for giving up so much of your time. Hopefully it's been slightly different in the driver's seat as well tonight.
I hope I've done Mr. Skern proud.
Awesome.
You've done fine.
Does anyone have any questions in the question? Because this is the bit where we can now go back and talk through any questions or queries or anything like that.
Okay. Sean arrived.
Oh, Sean, great, good. Well, let's start again.
Yeah.
CPC current, thermal effect insulation, dam, Connor Stanley. Oh, indeed. 3.2 on the earth. By the way, I've got pictures far higher than that.
Oh, God, yeah.
Pillar. New favourite test, clamp the installation dead. Indeed, it is a new favourite test. And I think, is it fair, can we say this on in? Why not? We might as well. We believe from discussions with the DNO that the earth leakage clamp test is going to appear in guidance note 3 before it appears in a future edition of the regs.
Yes.
Which, yes, needs to happen. Because if you think about it, chaps, this here, I'm going to be really sad. I know everyone can't see it. This is a PME. I've got a section of PME cable, concentric cable here. If you think about these new cables that we've got into buildings or the stuff that's in the streets, or if you look at our Instagram feed, the only thing that we have that's actually reliable is the line conductor into our installations. The neutral and earths are combined. The number of broken pens are going up year by year. So we are going to need to reconsider how we do our earthing and bonding and how we look at these diverted neutral currents.
Yeah, and again, this is something that has been a gradual observation, and we've looked into it further, and we found more information backing it up. And we found, other people looking into it, and I've actually found in standards like BS 7909, which is written back in 2011, which says about TNS systems really not being TNS systems anymore, and always being remedied or repaired to be PME systems, and only true TNS systems are the ones that are really on site. Public TNS systems are basically being tortured, and so these neutral currents that we're seeing, and we think about how much work we've been talking about PME, outside installations, EV, all that worry about PME systems, and what if our TNSs are also potentially going to have the same characteristics?
So I'm just going to read out a note in the UK Power Networks manual. All LV distribution networks should be assumed to be PME when providing new supplies, even if they were originally constructed using single neutral and earth (PILC) cabling. Therefore, all new installations should meet full PME requirements for equipotential bonding specified in 7671. The trouble is what they don't very much tell you is that the networks outside, every time they do a joint, is effectively PME'd. And if you look in Energy Networks Association recommendation G12, it openly states that you can have PME and TNS, but the fixed installation should be considered PME. But we're not told that.
I've got this bit here. This is C.4.2 from BS 7909, which is the temporary events. It says TNS for permanent systems. It says TNS was historically a common arrangement, is now rarely, if ever, used as a new distribution to consumers. Where existing TNS distributions have been extended or repaired, this work is typically carried out with concentric cables using a single conductor as the pen. Those parts of the distribution downstream of the repair or extension then have electrical characteristics that approach those of a PME distribution, but the consumers still see them to be TNS.
My advice to any inspectors coming across this issue would be to best practice, and now this is something that I'm going on the journey with now, and I posted LinkedIn a little while ago, is that for what we will be doing now is asking the DNO. Rather than assuming by looking at the cutout, we will be picking up the phone, spending 20 minutes and going, please confirm what the what your earthing arrangement is to this MPAN number, and then I'll be putting that. I would
So
say
there is an inherent danger in that, Neil, and we'll get on that in the next webinar, because it's fair to say that I've experienced this recently, where I had a cable blow at one of my stations in the street, and it's a 3-phase TNS head, and they jointed it with a concentric cable, making it PME, but the jointers weren't educated sufficiently or didn't really apply their own company standards. If you then say, here's an MPAN number, what is it? They may turn and say it's TNS, but the entire street is configured accordingly. You then go into, not that I'm being really sad or anything, but
the thing is, I can't be held accountable for a DNO's cock up.
No, but the problem is the consumers and the end users are going to be held accountable for the DNO's lack of maintenance, and this will then fall and transfer into the contractor.
Agreed, but in terms of doing inspection, I can prove due diligence and said, look,
I
didn't take what I saw as gospel. I spoke to the DNO. It's their equipment. That's what they've told me.
Okay, well, this is what's been happening over time. DNOs haven't been doing their thing. So we're now seeing the electricians are being asked to assess the condition of the distribution. We're now doing that on EICRs. What we're going to have soon, obviously, is the introduction of this clamp meter test to look at the potential currents that could be coming in, and then we'll be switching our earthing systems to TT, basically fixing the problem for them over time.
Yeah, we'll end up having our own earth electrode farm or an RA for every installation separate, because remember something, it's not just the earthing, it's the neutral. Yeah, if you lose your earth, you lose your neutral, which means then you potentially have a big problem. So we are going to cover this in future webinars. It may not be next week, it may be a month or so down the line, but we'll get there. We just wanted to kind of tease that premise, really, that we are looking hard at it, and I am reading every document under the sun on it. Right, what are the questions? Have we got any more questions before we finish this up? Always treat it as PME for Connor. Yeah, no, I don't disagree with that at all. I'm the same. DNO don't think they always know. The DNO records are in a state. They're in an utter state, to be honest with you.
The trouble is with treating things as PME, if you're going to go down as a VV, if we stay on industrial, external containers, loads of external containers and industrial metals containers, then we need to know. We can't just say, we can't assume it's a PME and then force a load of work that may not be necessary. I think it's good practice that we know what the earthing arrangement is.
I don't think it's forcing, because on an industrial...
There's a difference between a code and C2, isn't it? There's a difference between a no code and a C2.
Installation, Neil, what you're going to have is you're going to have a structure that's bonded. Now, that structure, you could then consider the foundations of that structure, your own foundation earth electrodes, yeah, which could then be your own RA. It could be your own neutral earth reference point, which still would provide a reasonable level of protection for the installation.
I'm going down to sort of steel containers, that sort of thing.
But if
it was a PME, I'll be looking at a C2. If it's a legitimate TNS, it's a no code. So it's a big difference there.
The key thing is
20, 30.
The key thing is legitimate TNS. It's a case of, I mean, right now all we can do is this test that was just shown as a way to assess. If we get no trace of current whatsoever, then that's fairly good confidence that there's no problem.
Mark Holmes has nailed it, and in G12 there is actually a reference that states about PILC cables can be effectively considered electrodes. So anyone who comes across a PME, there's a lot of this on social media at the moment where they're measuring more than 0.35. UKES Power Networks, all you got to do is just Google it, and there's a data sheet for electricians. It's on our Instagram. They allow up to 0.8 now, because they consider the PILC to be part of their electrode system. Now, I think it's also fair to say that the HSE and the DNOs are having lots of chats about their compliance with the electrical safety quality continuity regs. They're keeping it quite quiet.
Yeah.
Any other questions on coding and industrial?
I think we've kind of just directed the chat towards PME systems towards the end.
Yeah, well, we'll do another webinar now. We've got a lot more work to do, but the good thing is we're all emerging our knowledge, and we're all debating it, and we're all giving various scenarios, which is great, because all that does is improve our own general knowledge, and it drives that thirst and hunger to want to learn more.
Yeah,
we've just got a question here from Richard quickly. He just says, what if the containers are classed as permanent fixture, PME allowed? Containers can't be classed as a permanent fixture. Things that class permanent fixture would be permanent water supplies, permanent electrical supplies. Them sort of things make I
mean, they're transportable units, aren't they?
So
I had an installation at a National Trust building where we had a TT system, and it was all commissioned and all signed off. And the ZS or the ZE was fairly good, but then 2 or 3 of the actual containers after the erection left. And it was those things that were connected to the actual boxes that pulled the ZE that were giving it its low impedance. And when those things were removed, all the earths just went up.
And the thing is, Richard, what you've got to remember is the container doesn't know if it's temporary or fixed or permanent.
In fairness, I've
the
actually
danger's the same.
I have seen containers sat on sites for 20 years used as offices connected to PME supplies.
Well, look at schools, these modular offices, they're going up everywhere, you know, and the electric feed, the danger of the PME in the ground doesn't know that it's a temporary or permanent.
I think one of the things, there's evidently issues. I mean, if we do the research, there's evidently issues with the network with its age. I think one of the reasons why we're researching this and investigating it so much is because it's inevitable that the networks are palming off, and I'm going to say this brutally, we are as consumers being palmed off with the costs of everything infrastructure-wise that fails in this country. Now, what I'm worried about is good electricians who do the due diligence, who mitigate the risks that can occur, will end up suffering because we're going to end up having to put more and more technology and more products, because the wiring regulations may change in the future to mitigate the network's failure. And this is why Paul Skirm said it brilliantly the other day. Every time there's a broken pen, £1 million fine. Watch the networks change immediately. Now, I have actually spoken to the DNOs, and when PME was introduced in the late 70s, there was a plan in 40 years' time, because that's the life of the original PME cable, for all other services, gas and water, to be fully insulated. Well, that never happened because governments changed, which was the plan to reduce the risk of broken pens and exporting PME outside the equipotential zone. We are left with a mess that electricians are having to play catch up with.
And technology is taking us away from us, like EVs, hot tubs. They're coming more and more common, which weren't the case 40 years ago.
It is.
We thought about 40
and
years.
the thing is, it's a huge distraction because we're now basically hoping the technology will get rid of this other problem. You know, we see new technologies with EV, which are now being discussed. You know, so we don't know. We don't know.
EV. Yeah. Let's not.
That's it. Exciting times.
Yeah, we could do do you know what, from a technical perspective, and I've said this to a lot of the older electricians that I've met, years ago, it was inductive or resistive loads. It was very simple principles of selection, erection, understand the use, external influence and all that. Now we're in the era of mitigating network change, mitigating EMI, EMC issues, mitigating diverted neutral currents, mitigating mutual compatibility within the fixed installation, the connected loads affecting the protection devices. All of this stuff we never had to think about makes this such an exciting time. Brain melting, but very exciting.
And it's important. Don't be scared of it. Those are out there. Don't be scared of it. There's more resources now than there.
And we don't know everything. We don't know everything, and we won't profess to know everything. What we will do is we will try and poke, prod, and put stuff out there for open debate, because nobody's an expert in everything, and we don't profess to be, and that's really important. But other than that, if anybody's got any questions, yes, the lack of compliance does bore my piss. Agree, Daniel?
Right, next week we've got a webinar on intakes.
Yes.
Correct?
17 hours so far.
Now, we're not planning on going into this area of diverted neutral currents there, are we?
No, it's purely going to be coding of intakes and identification. So what I'm using is the Energy Networks Association guidance note, where they stole John Ward's pictures and we'll use that to help people identify the different types and age of cutouts and all the rest of it, and how we code. Can we code? What do we look at? And then hopefully the week after that, Dan will be ready with the fire alarms one, which will be very controversial. The fire industry will hate him forever for it.
We might tease towards the end back onto this diverted, but yeah, we'll have update on fire, and then we'll probably have this, because we've got, again, this neutral current is something that is fairly fresh, and we're getting more and more information, and we're basically just trying to just coordinate all the information that we've got and enhance our understanding of it before we can then bring it to you guys.
I predict a lot of FIs next week.
And that's it, really.
Yeah. Again, Neil, thank you for coming in, buddy.
Cheers, Neil.
Great help.
Thanks everyone for taking part. It's really been a pleasure.
And thank you everyone for watching and taking part indeed. And on YouTube, please don't hate us. It's far more enjoyable when you're doing this live Wednesdays at 7.
Yeah. Yeah, if you again, we go through a series of these, and if there's more interest in talking, in getting together and talk, then we can either do some of these again, or we can even do some like open meetings and stuff. We just want to use this platform as much as we can to get engaged and talking. Right, any other words from you guys before I press the end button? Any other things to say? Right, cheers, Bill.
We'll leave it for another webinar. Let's do some more controversy in the next week's one.
Take care. Bye bye.